Hello everyone, welcome back to another live stream of Totality Hio. And yes, today is day 14 of 75 Ultra Hard Challenge. Am I lagging? I think yes, my FPS dropped down for some reason. And yes, I'm really sorry for coming late a bit, actually, but don't worry, today there is no lectures. We're just gonna practice and revise the whole type of syllabus that we have been working on. And yes, let me just remove this part timer, and then um, right now I'll use it a bit for a while, and then this one too. And yes, we finally got a sub count. I don't know why it wasn't working last time. I reinstalled the app and somehow it started working out, which is actually pretty weird. And here I am. Let's go. Um, the sub count works. Nice. Right, yeah, it works. That's great. Let's go. I had to crop. That's it. And is it like a bit unsymmetrical? I don't know why. It feels like I'm actually having it a bit unsymmetrical. Let me just put it this much. Yep, okay. Let's extend this a bit. Chew. No, what? Oh, that's the wrong button I'm using. That's the function. Yeah, this one. Here we go. Now this is what I call a good streaming, but I need actually one more thing, like to put the live chat here on the stream itself so that everyone can see what is going on. And yeah, you guys can also do it. It depends on you. And I looks like the stream is working great. And yes, now I can finally get to know who's subscribing and who's not subscribing, because sometimes I have no idea who's doing that, and I would be really grateful for it, and I would appreciate it for you. And you can also check it out if you want to subscribe to my channel. You can see the subscriber rate increasing and decreasing. That's one such good thing. But yes, for now, let's start our work. You're not gonna give up. And I think the temperature today is a pretty good high. I like it. I don't know what's the temperature today is. Can I know the temperature? Temperature. How would I know that there's okay? It's 84 degree Fahrenheit here, which means in Celsius, how much is it gonna be? I have to convert it. Let me try. It's 84 Fahrenheit, 9 C by 5. Sorry. 84 5C by 9 plus 32. 84 minus 32, 32, that is 2. 83. That should be 52. And here you go, 52 into 9 by 5. That is here, that is gonna be C. I hope I'm doing it correctly. This should be, I have a bad feeling. No, I'm doing one thing wrong. 9C by 5, yeah, much better. 52 into 5 by 9. 52, 5 2 is 10, 5 5 is 25, 260, 260 by 9, 9 3 is 27, it's 9 2s, okay, wait, what? 9 2s are 18, 16, 8, 1 0, 0. That is gonna be 9 8s are 72, 8, it's 28, what? Wait, what? It says that it is in room temperature. What? Bro, it's really it's really hot in here. How's it 27? Sorry, 28 degrees Celsius. I'm confused. See, guys, trust me. I'm not a type of a Western person. I do not usually check Fahrenheit. In the temperature in terms of Fahrenheit. I usually check it in terms of degrees Celsius. So I convert it in from that for degree Fahrenheit to Celsius without using those, because I'm a science student and I've studied it. So yeah, it's basic formula there. That's it. Anyways, I'll try starting off with chemistry. Today I'll not be doing physics, I believe. Maybe. No, tomorrow. Yeah, tomorrow I may not be doing physics. But yes, today we'll be doing a lot of biology, a bit of maths, and very small amount of chemistry. I have to complete chemistry in 1 hour at least. So no, I don't need to. I don't have to do physics right now. I'll do it later because first the main thing I have to concentrate is on chemistry. Yesterday, if you don't know what I have done physics mainly. And yeah, I didn't stream at that time. I was off streaming study, and yeah, I streamed at night yesterday using my mother's mobile actually, and she was sleeping, and I had no idea how had that happened. Like, bro, that's crazy. Anyways, let's start off with some basic things. We'll start off with very, very small, and then I will go on with direct ones. We'll try to complete this under 1 hour. Oh, this will take some time. But hey, the notes are good, alhamdulillah. I feel like they're not that bad, but there are many of them. Where does it start? Does it start from here? No, this is dilution formula. Oh god, we had so many lectures based on this, that's why. Okay, where does it start? Okay, I think here. Yeah, here. Let's go. So let's start off with the solutions. It's a homogeneous of two or more non-reactant substances, where the components of the solution is solvent and solute. Solutions can be of binary, trimary, and I think quaternary. Am I correct? Am I saying it wrong? Let's check. Because sometimes we may be wrong based on that, and we need to be really careful. Yeah, it's ternary. My bad. Ternary and quaternary. So first of all, before that, jumping onto the binary, ternary, and quaternary, we need to understand the solution's uniform mixture, that is homogeneous. Homogeneous mixture means that there is a uniform mixture, or a good amount of mixture of the both the solvent and solute. Let's say you're adding salt into the water. If you try to take a spoon of water with a spoon, and you try to scoop out some water which is having some salt in it, you'll taste the salt, of course. But once you actually take another spoon from other region of that same solution, you'll still feel that same taste. It's because when mixing it, you're actually mixing it uniformly, which means that the same concentration or the same taste, you may feel it from different areas. So that means that there was a uniform composition, which means it is having a uniform concentration all throughout the region, and that is homogeneous mixture. Then we got this one small concept about the concentration terms, which we have studied in class 11th chemistry in the first chapter, mole concept, or known as some basic concepts of chemistry. Before that, jumping into concentration terms, we can say that if we have if we have a tank of let's say an orange juice, okay, orange juice, and then we try to scoop it up with a cap, a small cap, like the medicine caps where you try to take some amount of medicine, or we try to take it from a glass, the orange juice, okay, the glass, or we try to take it in a bucket. Oh my god, bucket! Who puts a lot of orange juice in a bucket? But yeah, we're trying to actually find out the taste, whether they're gonna vary once we take different amounts. So we have taken these small, those medicine caps where you try to drink those syrups, and make sure that you clean them, because you don't want those medicine mixed up with those orange juice, right? Yeah. So of course, when you try to drink it, you feel that same taste of the orange, if it is more natural. And and if you try to drink it with the orange juice where you have taken from the same tank, you'll actually have the same taste. And that means it shows the same concentration, uniform composition. And if you try to drink from a bucket, which is actually a bit of psychopathic way, very weird ways, but you still feel that same taste, which means that the concentration is same. And yeah, you can say that. So concentration terms have same concentration if you're trying to take from the same solution. But let's say that I actually took a tank of orange juice from one tank, and then I took a glass, okay, I took it from another tank which has a different concentration of orange juice. It has less taste. Then of course those two glasses I got, this will taste okay, that's good, there tastes more. But this one will taste less because I took it from a tank which has less taste. So of course this is a yap session, guys. Many of you may not have the idea of what I'm saying, but this is just for practice. If you guys want me to be muted, I'm ready for that, and I'll mute myself and do it, but it depends on you. For now, I'm just gonna say it because there's nobody watching me. I'll just wait for others. And also I'll select stream because I have forgot to actually do that because I have no idea who will be there, who will be watching me. I have no idea who's doing that. Whew! Okay, nobody's watching me yet. Let's go. Properties of solution. Solution has some properties which we need to know. Okay. Uh, we have studied different mixtures in ninth standard. If you have studied in CBSE, solution is actually a one type of mixture. There are many types of mixtures that you may have come across. Colloidal solutions or suspension solutions. Those come under the heterogeneous mixtures, which have non-uniform composition. Right? Like let's say sand and water. Okay, you'd put sand inside the water for a small amount of time. For a temporary amount of time, you actually find that out. The same, there will be concentration. Sand is mixed out throughout with the water, but afterwards see that the sand is actually getting deposited on the bottom side, which means that the concentration is getting different in different regions. So therefore we got the idea, right? Yes, we got the ideas. We actually are having some really great concepts going through the brain, right? Yeah, I'm actually going through the book and then I'm trying to explain it so that, yeah. Guys, we finished like two rules of metal and monohybrid and dihybrid cross W. Okay, so we are actually moving a bit fast. Okay, never mind. Each solution has one solvent and one more solute. Okay, we'll do that. So properties of solution shows properties of each component. Okay, yeah, the size of the particles. Now, those solutions, heterogeneous, who is a homogeneous mixture, we call them as true solutions. Their size of particles are very small, and they do not show Tyndall effect. What is Tyndall effect? Well, it's not there in the syllabus, but right now, because that was in ninth standard, so we can ignore that. Then each solution has one solvent, of course, and can have one or more solute. So you can have, let's say, a what can we say, lemonade. Okay, for a lemonade you need lemon juice, you need water, you need sugar. These three together can at least make, lemonade, right? I feel, maybe, yeah, I may be sure about that. So the solvent is water, solute is lemon juice and sugar. Okay, lemon juice means you're purely taking it from lemon. No, nothing else is added in that lemon juice. That's it. It's pure lemon juice, this thing, when you squeeze it up, right? And then we got water plus lemon juice. Yeah, that's one done. Solvent. The solvent is the one that dissolves. The solvent is the component that dissolves the solute, and solute is the component that gets dissolved by solvent. Yeah, that's a good gap right there. And then we got the physical states are decided by the solvent, which means that if the solution is in solid state, which means that the solvent is of course in solid state. If the solution is in liquid state, then the solvent is in liquid state. If the solution is in gaseous state, the solvent is in gaseous state. Many ways you can actually understand this, and then we can get the how we are gonna identify this. So the first criteria is that the components are different species. Let's say that you want to identify which solution has what kind of solvent, which kind of solute. Let's say this: I have sugar and water. I try to mix them. I get a sugar water solution. Now, sugar water solution is in what state? Liquid state, right? So the physical state is liquid. So how can I determine which one is solvent and which one is solute? Bro, the solute is sugar. Sugar is in solid state. So solvent is water, which is in liquid state. So water, the sugar, and then that gives you sugar water solution, right? Water sugar solution. How do you want to say it? That's your dependency, and yeah, that's what I can say. What am I missing? Okay. Next, what we can talk about is that, let's say the components are of same phase. Let's say this: I have a solution. I made an alcohol solution, which is haram, of course, but we know that ethanol and water are both are liquid. So how are you going to determine that? And that is going to make you alcohol solution, that is ethanol solution. So all of them are in the same phase. Ethanol is liquid, water is liquid, ethanol solution is also liquid. So how are you going to determine which one is solute and solvent? Now you would say by common sense that water is the solvent, right? Well, yes, you're actually right. But if I am being honest, the solvent and solute will depend on the amount. which means it may depend on the mass and number of moles. So if the number of moles of water is higher than ethanol, then we would say, yeah, of course it's a solvent. But sometimes there is a case. What if it happens that ethanol may have more moles than water? So some people may say water is the one that will dissolve the, ethanol will be the solvent, of water will be the solute. But here's the main controversy. In solutions, they don't actually consider solvent and solute much, but they may actually talk and study about it, which is actually a pretty big thing, and that's why this thing is there. But if they are not considering it, they will mainly consider water as a solvent for many of these solutions. That's what here they're doing. Okay, like let's say water is in lesser amount and ethanol is in more amount. Okay, many people will say it's water. That's fine, but if you're really considering it and if you're deeply studying it, we may say ethanol. So it is actually not wrong, but again, for the second other side, that's also not wrong, which is fine. You know what I mean? That's one thing you should know. Then there's something called miscible. Okay, now let's say that sugar is soluble in water, which means that they are getting dissolved. Similarly, for liquids, we use the term miscible. That benzene is miscible in water. Is that possible? No, sorry, immiscible. Immiscible. It does not dissolve in water. But yeah, we can actually dissolve benzene and toluene. Remember that benzene and toluene can be dissolved. They make a solution. Toluene is toluene is a compound which actually has a linkage of methyl, that is CH3, with benzene, and that is one such substance that is used for making TNT, trinitrotoluene. TNT. That's the name actually. Yeah, that's the name. That's the one thing you may have heard for sure. TNT. That's the one. Okay, now then we got the if the compounds are in same in mass, have same phase, then find their moles. Okay, you have to find their moles. Okay, let's say that the amount of that substance has same mass, same phase. Then how are you gonna do that? You're gonna use the number of moles. You're gonna find the number of moles and you're gonna get it. Okay, if you have no idea what I'm talking about, it's fine. It's be chill, because I know that most of my viewers are not in this grade, and of course, yeah. I may be wrong, but yeah, I'm pretty sure about that. Types of solutions in terms of number of constituents. Solution gives you solvent plus solute. That is two components, and that is actually one solvent and one solute. And those solutions are mainly considered in this whole chapter. That is binary solutions. But there are some other solutions which may have one solvent, of course, but one or more, like one or more, more than one solute. So let's say lemonade. Lemonade is a solution. It's a what am I saying? Ternary solution, where it has three components. That's what you can say. And here in binary for solutions, remember that the mole fraction of the component A, component B, let's say component A is solvent, component B is solute, those if you sum those up, you get 1. But in trinary, you have to sum up the A, B, C, solvent, solute, and blah blah blah. That's how. There is another solution known as quaternary, which is actually 4 components, solvent plus 3 solutes, and yeah, that continues. Now, types of solution in terms of physical states, we're gonna go through that. Physical states are of solution. Mainly, we discuss about gaseous, liquid, and solid. We do not go for Bose-Einstein condensate, or we don't go for plasma. Those are some extraordinary ones which we don't need to discuss. But right now, the ones we are mainly having, or we are usually, they are easily available. Like gas. Do I have liquid right now? I mean, my saliva has liquid, right? My saliva is in liquid state. I know that could be dirty. And then the solids. Yeah, solid states. Okay, so solids are also there. Gaseous are there. Liquid states are there. And based on that, solutions can be made of solid solutions, liquid solutions, gaseous solutions, right? Phew. Now, let's say for gaseous solutions, we have solvent and solute. If the solvent is gas, solute is gas, the solution will be gas, because solvent is gas, solution should be gas. If the solvent is let's say that. Okay, again. So can I give an example? Yes, I will give you an example. Example of this will be atmosphere. Then nitrogen will be the solvent, oxygen will be the solute. Why? Because nitrogen comprises 78% of atmosphere, oxygen comprises 21% of the atmosphere. There are other components like carbon dioxide, ozone, and others which are very small in percent, but oxygen is a bit major here, like 21% in solute, in terms of solutes. So I can mainly consider that. So yeah, this is a solution too. It's a homogeneous solution. It's a true solution. So yeah, then we got the those solutions which are having liquid and gaseous. So what am I gonna consider here? So in this one, you can say chloroform with mixed with nitrogen. Oh god. Yeah, also I forgot to mention that nitrogen gases are the solutions which will be used mainly for for making solutions. So liquid solutions, sorry, gaseous solutions where you have a liquid solvent, solute, liquid solute. So solvent will be gaseous because gaseous solution. So for the liquid solute, you would use chloroform. That same chloroform, that same chemical, CHCl3, which is used in literally making the person unconscious. They will put some chloroform in the rag and they'll kidnap a person like this. This leads them to be unconscious. They also suffer from side effects, and those side effects that they suffer may lead to death. Okay, my bad. That was so strange. Okay. Hmm. Well, okay, I'm so sorry, but so sorry. I don't want to traumatize anyone, but yes, chloroform is a bit dangerous. You have to be careful with that. That's why people usually use anesthesia. That is a medical type of chemical, which is used to make a person a bit like to make them unconscious for some amount of time. When because it's mainly used in surgeries because a person should not feel that pain when they're like conscious. They want to be unconscious for that. That's what it is. And dude, anesthesia is very powerful. It can make you go to sleep in under 10 seconds for sure. Not for sure, let's say, because some people have made it world record of going for more than 10 seconds. But let's not talk about that. But yeah, for solid and gases, that is camphor and the gas. N2, nitrogen. Nitrogen is the main solvent. He's the MVP. Now, liquid solutions. These are very common. If I so liquid solutions should have the solvent in liquid state. Yes, it should. Let's say I have a solute which is in gaseous state. So how am I going to do that? Can I say soda water has carbon dioxide in it? Yeah, that's correct. Can I have water which is oxygen dissolved in it, like the ocean water? Or because that's how fish breathe, right? Fishes won't, bro. Fishes need oxygen too, so they will have dissolved oxygen from the water. If they do not have oxygen in the water, yeah, and that's why they die in the aquariums because they do not have filter. Filter provides them dissolved oxygen. Remember that, guys. In aquarium, that's why they put it because aquarium cannot naturally provide oxygen, dissolved oxygen. Remember that. So oxygen with water is also a liquid solution, where water is a solvent, oxygen is a solute. Let's say a solute is a solid, solvent is in liquid. Sugar water. Can we say that? Salt water. Okay. Those are the main classic ones we know. Any others? Glucose with water, is that correct? Let me just check. Oh yeah, glucose dissolved in water. That's correct. Uh, then we have this one too. Liquid and liquid. Yeah, those are I have already discussed about it. Ethanol with H2O. That is one good solution which has both liquids. Solute liquid, solvent liquid, and the solution itself is liquid. Then we got the solid solutions. You make solutions from solids? Solid solutions? Yeah, it's possible. Mainly the alloy metals. These alloys are basically known as metal solutions. Let's say bronze, and then we have brass. These two are mainly the ones, actually, I know. Then the amalgam. Amalgam is also there. Amalgam is an alloy. Okay. Mainly alloys are considered. That's what you need to know. Okay. So this one is a bit interesting. I want to actually know all about this. Okay. Wait a minute. All right. So solutions of solid solutions. Solvent could be solid. Solute could be solid. Solvent being solid. Hmm. Solvent being solid. Solute being solid. What can it be? Your brass, copper and zinc. Copper is 70%. Zinc is 30%. Bronze, copper and tin. I don't know the percentage about the this one because it's not mentioned, I guess. But I know for brass it's 70% copper, 30% zinc. Because they didn't mention about it. I remember. Yeah. And then you can also talk about this too, right? Copper is dissolved in gold. The females who wear ornamental golds are not the actual pure gold because those pure golds are a bit soft. They can be bendable actually by stronger forces, not like normal forces, but still they are bendable. So they are mixed with copper or and silver not platinum, I'm not sure, but yeah, they're mixed with other strong metals so that the ornamental metals don't break, so that they can be strong. Yeah, I've also seen that the ornamental metals are very very thin, very very thin. So it will be easily breakable if that wasn't no ornamental gold. If it was a pure gold, then yes, of course it could have been broken. And then what else? Liquid solid amalgam. What is amalgam? Your mercury, sodium amalgam. Okay, so mercury mixed with sodium. Sodium is a solid. It's a solvent, and amalgam, mercury. Mercury is the liquid metal. I know. I'm pretty sure that many of you know what is mercury. It's also known as Hg, hydrogarum. Uh, it's just a chemical name. That's it. The other name of it, like um, gold is known as aurum. Then what else? Copper is known as cuprum. And many many things. Metal amalgam, what else? Sodium amalgam, zinc amalgam, brass, bronze. Oh yeah, German silver. Zinc and Ni will give you copper solvent. Plus this and this and that. That Wait a minute, guys. I'll just check. I'll just check my screen. Okay, let's go. I was just checking my channel. That's it. Okay, concentration terms. You know what? Let's go. Actually, let's keep the pace a bit faster now as we're progressing. Concentration terms. So concentration terms are those types of quantities, or you can just say, that are used in finding the amount of concentration in terms of, mass or volume, or you can say in other ways. Let's say, let's start from, very very basic. If you want to know how exactly the amount of composition of solute you have, or how much of composition of solvent you have, or how concentrated the solution is, or how diluted the solution is, you use the concentration terms, and those are mainly for quantitative analysis. Okay, so molarity, molality, mole fraction, mass percent, volume percent, mass by volume percent, then percentage volume, then hydrogen peroxide volume strength. That those two are not that important. Then it's not even there in the syllabus, just if so you know. And then what else, more fractions discussed, yeah. So actually, like, you know what, even formality, normality, oh yeah, I forgot about that. That's kind of important, right? Yeah, let's go. So let's start off that. Molarity is equal to the number of moles of solute in 1 liter of solution. Okay, that's one thing we can mention, or we can say 1000 ml. So I'm gonna actually go fast. I'm gonna read out the topics, and that's what I'm gonna do, because we have to do it in time. Okay, this is yapping session. Like, I'm not gonna actually like explain more. And of course, if you feel irritated, please comment and say I should be muted. And yes, I will be muted, as from your demand. I will be ready to do that. And yes, let me continue. I'll do it fast, okay? So molarity is equal to number of moles of solute divided by the volume of solution. Number of moles of solute can be also said molarity into volume of solution, and it is actually pretty useful for it has another formula. Yeah, formula is molarity is equal to mass percent into 10 into density divided by molar mass, which is not much used. Now molarity is temperature dependent because it has volume in it. Okay, I have to put my charger in. And the molarity having the being temperature dependent is because it has a volume in denominator, and volume is temperature dependent. That's why. So yeah, you can say that. If I have, let's say if I have 0.1 molar NaCl solution, I would say 0.1 mole of NaCl is present in the 1000 ml or 1 liter of NaCl solution. That's how I'm gonna say it. So that's one such ways you can actually find it out. Then we can look at some ways and blah blah blah. Let's go and mute. Pew, pew, pew. Shoo, 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 shoo. 3C and 2C. We take that, and then you actually take this IC. You are taking this, so BaCl 3BaCl4 plus 2AlCl. Na2O plus H2O gives 2NaOH. Okay. We have to go through the reactions just in case if we make any mistake, because that's one thing we have to be really careful of. Resultant molarity during dilution. H2O M1V1 is equal to M2V2, where let's say that the number of moles should be same because the solution number of moles cannot be changed. That's why. So that's one thing we need to know. Moles of solute remains constant, volume increases, molarity decreases because we're actually diluting it. That's why it's known as dilution formula. And then we got M1V1 is equal to M2V2, M1V1 by M2V2 is equal to M2. Then yeah, that's how you're finding it out. Yeah, this one. Yes, M-net value. The resultant molarity when you are mixing the solutions, that is M1V1 plus M2V2 divided by the total volume, that is V1 plus V2. You get it by M-net. Okay, so that's one thing. 1 minute. I feel like I've missed something, but no, it's not. Okay. Okay, this one is good. C. Concentration C. Okay, I believe that I can do it. Wait a minute. 3 moles. 3 mole by 100 by 1000. 30 mole. No, wait. That's pretty much a lot. Oh my god. Thirty molarity, huh? See, wait. Oh. We are finding out. I don't know why I'm messing it up. I shouldn't be doing that. It's for 3 Na plus. I see. Next is molality, which is actually great. We were moving fast, but I think we have to keep the pace more faster. That's what I'm saying. Because, I have to also go through some questions as I go on and I move on. That's what I want to do. Moles of solute divided by weight of solvent in kgs. Yeah, that's okay. And molarity and mole fraction can be done together. That's great. Wait a minute. I'll check the thing. We'll be doing the test today. Okay, guys. We have to do that. Or that's very important. You have to change the class too, right? Yes. Wait. Here we go. Confirm. It is live. It is a live test. When it will end? It ends on 7:30 p.m. So have to be fast, guys. You have to be really fast. 60 minutes and 96 marks. So we earn 120 XP from that, which is pretty good. We have 24 questions to go, and we have to be really locked in. This is gonna be a bit very important thing for me. It'll take some time. I'll try my best, and yeah. But before that, revision. Let's have a revision. Okay, let me try to do this once in 3.45 a plus here actually. Yes, so is it for sure that I have 100 or 1,000? Now that's in grams now. So any solute is solid, right? So we 58.5. We have 10 here. So 34.5 by 58.5. That is 345 by 585. Let's go. Let's divide it by 5. That is 34, 5, 5, 6 are 30. 5 9s are 45. Pretty weird number, 69. 5 5. 5 1s are 5. 5 1s are 5. 3. 5 7s are 35. 117. Now 69 and 117. 117 is actually divisible by 3. Let's try that. Even 69 is. That is 23. That is. I think it's. I'm not sure. Let's check. 3 2s are 3 2s are, no, 3 3 3 2s are 6. Yeah. 3 3s are 9. Oh, 3 3s are 9 is also possible. 0 2 3 3 9s are 27. So 39. 23 by 39. Let's do that now. That's a bit simpler. 0 23 0 here 23 230. 39 into. I'm not sure if I'm correct in this, but let's try. Let's try. I don't know why, but I have a strong feeling that I'm going wrong. But why? Um. Oh, I made a small mistake. Okay, never mind. But I think my approach was correct here. So that should give me 1.5 mole per liter, which is Na. Okay. 1.5 mole per liter is Na. Plus, by the way, just remember that. Okay, got it. Okay, got it. Okay, let's move on. I don't know why I got stuck there. Just wanted to check. 0.2 moles of solute, or let's say NaCl, in 1 liter of solution. Nice. 0.0. Okay, that's 0.08 moles of KOH is dissolved in 1000 ml of solvent, not solution, not solution, solvent. Mole fraction. Chi A is equal to, let's say there is a ternary solution. So there are three components. So that's going to be chi A, chi B, and chi C, which means there are three components. So number of moles of these three components will be different, maybe, or it could be same too. So Na plus Nb plus Nc. Okay, so sorry, Na, so Nb and Nc. Then we try to find the mole fraction of first component chi A is equal to Na by Na plus Nb plus Nc. For the second component chi B is equal to Nb by Nb plus Na plus Nc. And then we got chi C, which is Nc divided by Nc plus Nb plus Nba. You can arrange the orders if you want to. I mean, I think you may not have got about it, but it's fine. Because you don't need to study this, of course. Then chi A plus chi B plus chi C is equal to 1. For a binary solution, chi A is equal to Na by Na plus Nb. For chi B, it's gonna be Nb by Na plus Nb, or you can say chi Nb is divided by Nb plus Na. It is commutative. Addition is commutative, so it's fine. Chi solute or chi plus chi solvent is 1. Independent temperature, yeah, temperature independent, which means that it doesn't depend on temperature. It has mass in its denominator instead of volume because it's not molarity, it's molality, litty, not ritty, litty, molality. So molality is just like totality, that's similar molality. So molality is actually, number of moles of solute in 1 kg of solvent. That kg determines that physical quantity that we are using is mass. So that mass is not temperature dependent. It does not vary with the temperature. Volume does. So remember about that. Yep, you don't need to. My bad. 1 minute. Yes, here we go. What am I doing? I'm just going through it. That's it, guys. Don't worry. pH is equal to minus log H plus. Okay. Okay, we're taking molarity here. Okay, nice. Molarity is found here. Alright. Okay, there's pretty much of practice questions here. Oh yeah, did I mention about ppm and ppb, parts per million and parts per billion? Maybe not. Yeah, that's also a concentration term too. There are many concentration terms. I think the most time I might have to take for revision is percentage volume and the volume strength of the hydrogen peroxide. It will take some time. The rest all will take less time. Let me just check till when that part will come. Okay, wait. We are actually close. Parts per million, parts per billion. Okay. Pretty much a lot of questions here. Done. And then we just started from here. Percentage volume and volume. It's not much asked, but let's check. Strength of solution. Oh yeah, I forgot about that one too. How many concentration terms are there now total? Molality, mole fraction, percentage compositions like mass percent, volume percent, percentage weight by volume. Then we got parts per million, parts per billion, formality, normality, percentage volume, volume strength. Um, what else? What else? What else? What else? Is it this much? No, wait. It's like more than 8. No, more than. Yeah, they're pretty much. Actually, 10. There are many, many of them. I'm actually shocked. Okay. I did not realize that. I know that I've studied a lot of these, but yeah. I think the percentage volume and volume strength will take time. Okay. Mass percent, weight of solute by weight of solvent divided by that, and is that weight of solution in 200, not solvent. So if you want to write this in English sentence, you will write it as, let's say 0.8% of this thing is there in mass. So I would say weight 0.8 grams of solute in 100 grams, because 100%, right? So percentage, so 100 grams of solution. Then it is temperature independent concentration, because totally this composition has only mass in it, no volume. So yeah, temperature independent. Yeah, you can say that. Tiny seal. I think I should have done that here too. Weight by. Now what about the weight by volume percentage? It's, see, weight by volume. This one here is a bit different. You will say weight of solute divided by volume of solution into 100. Wow, we have already covered this in 1 hour, dude. 1 hour. Wow. Okay, not bad. We have completed half of the work in just 1 hour, which is pretty good, I would say. We're progressing, guys. We are doing great. We're progressing. So, 11 grams of urea in 100 ml of solution. That's what we have to check. Urea is NH2CO NH2. And then I also asked, and then yes. Parts concentration term, parts per million, ppm. These are for the highly diluted solutions where the weight. Actually, did I check this one? Also, weight by volume will depend on temperature, because volume is there on denominator. Yes, temperature dependent concentration term. Okay, I think yeah. Yes, I did not miss any part. Yes. Parts per million, highly diluted solutions. Weight of solution in grams divided by weight of weight of solute by grams, divided by weight of solution in grams into 10 raised to 6 is equal to ppm. That amount of ppm will be given. And then for parts per billion, ppb, that is going to be weight of solute divided by in grams, weight of solution. It can be also written in grams, no problem. It is equal to 10 raised to 6. 10 raised to 6. The 10 raised to 6, sorry, 10 raised to 9. 10 raised to 6 represents million, 10 raised to 9 represents billion, and that is going to give you ppb, parts per billion. But it isn't not here. I have to check this. 10 ppm CO2 in H2O. That is 10 grams of CO2 in 10 raised to 6 H2O. That's what it means, right? Oh yeah, that's correct, because if you look at that, the solvent is pretty much big. The solute can be negligible, in fact. If you're taking the mole fraction, right, so you can actually take Na by Nb, because solute is, moles of solute is also very negligible. Okay, let's go to These are for those solutions which have very less amount of solute, very less amount, like you cannot even, you know, if you try to taste those diluted solutions, right, those highly diluted solutions with edible solutes, you'll have no idea whether there was there in the, it's that less concentrated, it's that diluted in fact. Okay, I can actually lean nicely like this, kind of gives me some heat. Rate of solution is approximately equal to rate of solution. No, am I missing something? Oh, strength. Where's strength? Strength is out. Okay. Wait, what about ppb? So let's say 10 ppb or 5 ppb of NaCl and H2O solution. Sorry, this NaCl solution. So I would say 10 grams of NaCl and 10 raised to 6 H2O, or 10 raised to 6 of that solution, or 10 raised to 6 grams of solution. Sorry, 10 raised to 9, that's ppb. 10 raised to 9 is ppb. The 10 raised to 6 is ppm. Percentage volume by volume. This one is not much used, but it's kind of better to learn it. Volume of solution divided by volume of volume of solute divided by volume of solution into 100 is going to give me volume. So 10 ml of methanol in 100 ml solution in sentence. Note, if any gaseous mixture percentage air volume by volume is also treated as per percent. Oh yeah, that's kind of true too, because if you look at it, the mole percent, okay. The reason why I'm saying mole percent is because volume's denominator is actually common. It's 22.4 in STP. Is it? Or I think it's 22.4 in NTP and 22.7 in STP. I think that's what you can say. 22.4 liters in STP or NTP or in NTP. I want to know that. It's 1 mole, 22.4 liters, but it says STP. Oh, let's say 22.7 then.
They don't know.
24.4, 22.4. Okay, so 22.4 is NTP. Then what about STP? 22.4? Okay, that's kind of confusing, by the way.
To be honest, I think I can't help.
Oh, it says that they are using the 1 bar of pressure to define the molar volume as 22.7. I see. Very interesting. So 10% of volume percentage of methanol solution in water. Methanol in water.
And when I'm close to you,
In aqueous methanol.
But
that's much better actually. That's gonna be 10 ml of methanol divided by 100 ml of the solution. That's methanol solution into 100. Sorry, not 100. And this volume of solute divided by volume of solution into 100. Not much important. I feel like the questions are really good in this one. Strength of solution. We are close, guys. Yes, we are really close. Then, first of all, we'll do strength of solution. You know what? I'm gonna directly jump into normality and formality, and then we're gonna do this percentage volume and this volume strength. What do you guys think? Vapor pressure, is it there?
I mean, there's like, it's actually really popular, not
Test solubility.
it has
Concentration terms and solubility.
especially
What? I don't know what topic is it referring to. Is it?
so how is so many
You know what? Let's first complete this. Then we'll move on to this one, which will actually take a bit of time.
everywhere, every single time.
Oh shoot, that's a lot. Part? Yeah, okay. Let's try. Raoult's law too, right? Yeah. Raoult's law. I'm not sure what this solubility is referring to, because solubility is there in Henry's law, and it is also there in Raoult's law for like in a bit. Now, I mean, what I mean is that Raoult's law is a special case of Henry's law. That's why. And vapor pressure is one such thing, right? Let's check. At sharp 5 o'clock, we're gonna do the thing. We'll be locked in. Because before 5 o'clock, I have to pray and then we'll do that.
Yeah, so this is the kids' books section, basically. And there's so many
Minors and cofactors.
you're not only going to be here looking at price you're also going to be kind of
We have did this one. Temperature dependent ones. This one is done. Strength of solution. Weight of solute in grams dissolved in 1 liter of solution. That is, weight of solute in grams dissolved in 1 liter of solution. That is grams per liter, not moles, grams per liter. And that is weight of solute. Weight of solute instead of moles of solute. That's what strength requires. But if we add molar mass and divide it with the grams, then we get molarity. Now temperature dependent, yes, liter volume. And let's say if you want to write this in English, let's say we have 1.3 grams per liter aqueous glucose solution. So we would say 1.3 grams of glucose present or dissolved in 1 liter of aqueous solution of glucose. That is nothing. Finished, right? Yeah. Formality. Formality is a bit easier. Number of gram formula mass of the ionic solute dissolved per liter of solution. Formality is just like molarity, but normality is a bit different. It has a gram equivalence, which we have to look out for, and it's not that hard actually, I would say.
It's like the 90s. Not really, but
There was one we were watching, I guess I just saw someone.
okay, let's. Okay, so basically the most thing that mostly hours. So if Yes, it's pretty good. The writing is good. The animation is something, but it took me literally 20 hours to literally animate.
Numbers of gram formula mass of the ionic
5 seconds.
solute dissolved in per liter of
5
solution.
minutes. And it took me another but then when I got with the hang of it, took me
Number of gram formula mass dissolved in ionic solute. Ionic solution. What am I saying?
5 minutes.
The ionic solute dissolved in 1 liter of per liter of solution. This is moles per liter actually, because gram formula mass is nothing but moles of solute.
Okay, let's do it.
Grams formula mass is
Okay,
nothing but moles of
here,
solute.
as you can see, this is where, this is where all, this is my book right now, basically. This is where I do
Oops. Yep.
plan out all of, do my research and plan out all of my research. They're not like, I'm just like,
So again, formality, it's just like molarity. It is number of gram formula mass, which is the number of moles of solute, divided by volume of solution in liters.
yeah, so,
The normality, right? Normality.
yeah, I'm gonna see you later.
Normality is a bit, which one we have to be really careful of. It is the number of gram equivalents of solute present in 1 liter of solution. So number of gram equivalents of solute divided by the volume of solution in 1 liter. So equivalence is actually moles into n factor, and n factor is one thing we need to find out. N factor for acids, base, and I think it's there for salts too. Yeah. You multiply these or no? You multiply this, this, this. So a number of gram equivalents of. Yo, DIK, how are you doing, man? What's good? How are you doing? Okay, what is normality? Normality is the number of gram equivalents divided by the volume of solution in liters. Now, what is gram equivalent? Gram equivalence is equal to, or just say equivalent, it's equal to number of moles into n factor. What is now n factor? N factor values for acids, that is known as acidity, basicity, bases, and salts. Okay, salts, cation, and anion. The charge and how we're going to find out. So for the n factor of acids, we are going to see this through the help of H plus, and for bases we are going to see this through the help of OH minus, and for salts we are going to use both cations and anions to just check the number of the charge and also the number of these the charge on them, and also the number of ions in that salt, the positive and negative radicals, not together. Just take one of them and try to check the number of number of ions and the number of the charge number in them. So normality is equal to number of equivalents of solute, actually it's gram equivalents, and divided by the volume of solution. Let's go. 1 minute. Yeah, here it's 1. This one is 2. This one is 1. How much of H plus is released? Oh yeah. This is acidity. What? This is 2. This is 2. 2. 6. 6. 1. 1. Let's say N. Normality into volume is going to give me gram equivalents of solute, and molarity into volume is going to give me the moles of solute, number of moles of solute. Normality is a bit unique actually, and it can also undergo the dilution. Normality is also like molarity, just like formality. And then we're gonna check this out. It follows deviation. Sorry, not the deviation. Dilution formula. The gram equivalence of solute will be equal for when you dilute it again, and then you can also do that for the same of the net of the normality. I believe. Yes. Yes. Okay. Normality is equal to molarity into n factors. I would say, not number of moles. Right. Next is vapor pressure. Before that, next we have to study is volume strength of hydrogen peroxide and a percentage labeling of oleum. 10 cubic centimeters. Taking some time to revise it, but it's fine. It's fine. It will be useful. Guys, I just wanna say one question. Uh, you know, I have a question. If you want, you can answer it in the comments. If you're watching it recorded, not live, and if you're live watching me right now in present, then I just want to say that, um, like, what should I take a holiday from school, like on any of these random days in this week, or should I do not do, or I have to not do that for this week? Because bro, I have to actually practice this one maths chapter, and I have to strong it, make it strengthen. I have to strengthen that maths chapter. Plus, I may get some time for physics. Maybe, like, there's one chapter I have to study for the school level. I'm just saying. Volume strength of hydrogen peroxide H2O2 solution. Tag 10 cubic centimeters. 1 ml of H2O2 solution. Decomposition 10 ml of this O2 formed at STP. I think it's better to learn the formula instead, like going directly into the thing. Like let's say if I want to learn the volume strength of this, I would say 11.35 into molarity at STP if it is given at 22.7, and 22.7, and then if it is in molarity, so volume strength of H2O2 is equal to 11.2 into molarity at NTP. But let's still go through that. 22.7. So if I take a sample of 10 cubic centimeters from this, that is 10 ml, then I should be taking 1 ml of this H2O2, and I get 10 ml of oxygen. That's what you're saying, right? At STP, yeah. At STP, I would say 22.7, and at NTP, I would say 22.4 in this case. For volume strength of H2O2, this will be 11.35, 22.7, right? That's 5. And here it's 11.2 to 22.4, that's why. Okay, into molarity. Okay, I think volume strength is done. Now let's do this. 100 grams of this. Okay, percentage labeling of volume will take time. and then we'll move on to vapor pressure, which is the last part, and then the compensatory revision will be done. Next is mathematics. Okay. Today there are no lectures. Just remember that. Okay, so oleum is basically the mixture of H2SO4 and SO3, and it is also known as fuming H2SO4. You know, H2SO4 is a strong acid, and there is a fact that if you apply water into this fuming H2SO4 or this oleum, more amount of H2SO4 is formed. Why is it that? Why is it happening like that? Why is there more amount of H2SO4? Is it breaking the law of conservation of mass? No, it's not. The fact is, the SO3, which I have mentioned earlier, is actually along with H2SO4. So that SO3, when in contact with water, will react with it and forms extra amount of H2SO4. So that's new amount of H2SO4 formed along with the old H2SO4, which was there along with the SO3 earlier. Now, once we have added water, it is getting even more H2SO4. So that's one such things we can say. And then we are going to talk about percentage labeling of oleum. I think this one will be a bit tougher. I'm not sure because this is an advanced level thing. It's an advanced level concentration terms. This is molarity, right? Hmm. क्या करूँ मैं chemistry को? Okay, let's say we have 109% of this percentage oleum. 109? What's that? Why is it more than 100%? We usually say it for 1000% effort, 1000% hard work, infinity% power. I know we say that a lot of times, but in scientific way we are saying more than 100%. That is not making sense. Well, actually, we are. The reason why I said 109% is because as you know, we are getting extra H2SO4, and that's why. So let's say if you're taking 100 grams of this oleum and you're adding water to it, it gives you extra 9 grams of H2SO4. That's why. So it's 109 grams. You got it? And SO3 plus H2 gives you H2SO4. H2SO4 total gives you H2SO4 old plus H2SO4 new. And then I need to learn the formulas. You know what? I'll actually note these down. Where should I note it down? This book? No, I want to use it for maths mainly. I don't want to actually use it for other purposes. Now wait a minute, let me think. I have a small doubt too. I have to check my timing when I should be analyzing the test papers or then when I do it, because That way I can actually get to know what all questions I've made mistake and what all questions I've made correctly. And this is not going to be an easy paper. It's going to be tough, of course tough. I know it for sure, and I have to be prepared for it. I have a belief that I can do physics and chemistry nicely for this test, but not maths, I feel. Because maths I've studied a bit less, and plus my maths is actually not that good right now from this point of view. I have to practice more and more mathematics. But physics and chemistry, yes, I can say that I've prepared for it. But yes, I'll just revise more chemistry and then that's prepared. Oops, oops. Ouch. Oh, yeah, let me do that. VSO3 labeling. VSO3 labeling. if it is 100 grams. Checking the number of moles of this and this. The maximum we can have is 100 grams of SO3 in this. I see. I think it will form more of these H2SO4. That's what I know for sure. Okay, guys. 1 minute, I'll come back. Okay, just wait. We have completed most of the parts of chemistry. Uh, the concentration terms, which is the main big part, is done. Now we have to do vapor pressure, and then we'll move on to mathematics. We have to do it as fast as possible, guys, because we have to try to start it at sharp 5 o'clock. That's why. Plus, I have to be ready because I have to pray and then do that. Just wait a minute. I'll just check. I might have to eat lunch. I have to just check once. Here we go. I'm back. Sorry for being late. Uh, should have put a timer at least. But I've, sometimes when I don't put a timer, I just don't get the idea of time. Because I usually check my timer whenever I go off away. Charge is draining a bit faster, I guess. Okay, now it's fine. Okay. Oh, so wait, I will try practicing this once. It's like this. You're actually having 5 grams instead of 9, but still, you try to take this. You get 2 moles, and that 2 mole you get. Sorry, 1 by 2 mole, and that 1 by 2 mole you get. You or applying that for the same. See, like S2, SO3, S2, SO4, right? So half moles. And that SO3 has molar amounts of this will be 80 by 2, and that is 40 molar. Sorry, not 40 molar, 40 grams. And then further insufficient has to over here actually. What it was supposed to be was 40 grams plus, sorry, into this amount of extras, it's 5 by 18. That is the in terms of moles. Wait. Then why are we putting this in terms of moles? SO3 80 grams. Sorry, 40 grams. That is acting as a factor, as in the form of mole. Oh, okay. Hmm. Okay, that's actually a bit weird. 100 by 9. That's 11.1 grams of SO3. Percentage labeling. 100 minus x plus what? 100 minus x. Sorry, x by 180 into 98. That is percentage labeling. And percentage labeling minus 100 into, sorry, by 18 into 90. Is it 90? I'm not sure. Is it? It's 80. Is equal to percentage free S3. Okay. Okay, guys, just tell me this one thing. Should I study maths first or chemistry? Because I have test syllabus for maths. I feel like I'll start with, I'll start with maths, and then we'll revise the whole chemistry, till what we have learned. And we are actually now in a pretty good state. We have completed a lot of parts. This last part will take some time, so yeah, I'm gonna switch to maths. I'll try doing that, and then at the last moments I'll just go through this paper project. I'll use my notebook for practicing. have to go through the 11 concepts, right? Till general properties, I believe, right? Introduction, minor and cofactors, and general properties. Okay. Let's start off with the normal ones. Where is it? Go. Okay. Determinants, important in boards, mains, advanced, compact forms or shortcut forms to represent a number or an expression. So determinants is something which will be helping us in compact form or shortcut form to express the expression. Alright. Intro, order to, that is two columns, two rows. Order two, that is called, sorry, what I'm saying, order 3 by 3. Three columns, three rows, and the element is a, m, and a, mth row and its column. That's one thing. Then determinant of order of 1 is the number 1 itself, 1 by 1, that is 1, x, yeah. And then 2 by 2, the a11, a22, a21, a22. But 3 by 3, a11, a12, a13, a21, a22, a23, a33, sorry, a31, a32, a33. Number of elements will be here, n square, and yeah. N by n is actually a11, a12, a13, dot, a1n, and here a21, a22, a23, dot. Actually, I will complete that. A23, dot, a2n, and here it's gonna be actually 3, 1, 3, 2, a33, dot, a33, a3n, and then you can keep this. Sorry, माशाल्लाह कुछ का बाद में थोड़ा dot. Bueno, coño. मारो ना कोई बात मुझे सारा. I'm so sorry, guys. I know, sometimes I feel like I'm actually doing a mukbang stream whenever I eat, but actually I don't like doing that much because it's like you're showing off the food because to the hungry people. That's why I try my best to usually avoid to show my food. But yeah, I might have to eat though. I cannot eat by closing my camera. I have to keep it at least open, or else people will think like, where am I?
2 मिनट
और
बैठ
क्यों
को
बुखार को तो अब बैठने को बस।
पास बैठना को
हाँ
जरी दूर बैठ को बात कर लको अच्छी है क्या तबीयत पूछ को खा लको आजा हाँ
टेस्ट का है कि बुखार को?
2 मिनट
1 minute, guys. It's a bit urgent, man. I don't like leaving the stream again and again. It's kind of irritating sometimes. It may be irritating for you guys especially too. Anyways, I'll come back. Okay, I will take my book. Just wait for 10 minutes. Oh my god, I hate it. Man, I feel bad. I gotta come. Man, I really feel bad, but I have to. I'm so sorry, guys. I'm extremely sorry. Finally, guys, I'm back. I'm extremely sorry. Man, I knew that I have already passed the time. There's so many work things I have to do all at once, and I came as fast as possible. I literally came back running, I guess I would say. Well, not running, but yeah, I was walking really fast. Okay, here we go. Here continue. Oh, this is maths, yes, of course.
Okay, we have 10. Oh my god. Wait, on day 26, we're going to do letters aside. Probably right. All of them. So,
Oh, come on, come on. What am I doing? I'm actually a bit slow here. Yeah, here we go. Yes. Total elements in this will be n square, order is n by n or order n, number of diagonal elements n, number of elements on the upper portion is n square minus n by 2, our lower portion is n square minus n by 2. That is the above the diagonal, the portion of the determinant above the diagonal, and the portion of the determinant above the, below the determinant, below the diagonal. Yeah.
so this is, I wrote the first one to 9.
Hello, नजर एकदम screen पे. चलो, let's try this. 3 by 3, right? Let's try 4, 6, 3, 2, 8, 1, 0, 7, 9. Let's try this. Okay. So we'll do it from faster method because I don't want to waste my time. 0 minus 14 minus 6 into
say that you have to say that
that's right.
Right. You have to. Oh my god.
Plus 20.
Okay, that's not bad.
72. Most of these numbers are negative.
Oh my god. Wait, okay, this one is not bad. This one is not that bad too. Okay, it's not bad.
Love that though.
Oh my god.
56.
They all don't look the same. I'm not that crazy about, but hey. You first say that you have to say that too. Look at this one. That's so perfect, arcade. Let's do this one again. I don't like it. I don't like this. Hey. Yeah, there we go. I definitely like it. Okay, you guys. I think we have master day, so I guess I should celebrate it. I don't know. We're gonna see. Maybe I'm just being too confident, but I don't know. Now I'm getting kind of like used to writing. Used to writing.
जी मैं सच में कर रहा था किसको कर को मैसेज कर मैं भी मैसेज करता था.
Okay.
Listen guys, it was just my sister acting as a YouTuber, that's it.
You shut up.
But I just want to ask, you want to become a YouTuber?
No.
But then why do you act like one?
Then why do you? If you want
because
to become
I have
a
a child.
YouTuber?
Yeah, I would like to be I do like to be a YouTuber. Yes.
Then what are you studying for?
Maths. Okay, never mind. No, I'm not roasting anyone here, by the way. I'm just talking in a serious note. On a serious note. My English bro, what's going on?
No, you have to look at this. And you're like,
121.
wait, this has to be
121.
Like, look how perfect. Okay, we have this. Look at this C. Look at it, and then look at this one. It's so perfect. Is it the pen? I think it's the pen. Let's go with. Oh, okay. The C's are pretty easy, I will say. No, the things that I'm getting hacked right now, it's pretty good. Can we do that spin?
Okay, we are cracking determinants. Let's get a small one. 3, 4, 2, 1.
Oh.
That's the determinant.
I'm gonna keep that. Okay, you guys, please. Come on. It's like, come on.
Haha.
I need to do this. You guys, come on. Look at these letters. Okay, I think I don't like this one yet. So I'm just gonna cut it. Cut it off. Perfect. Look at this. Are you seeing this? It's so good.
Oh, girl, stop it. I'm getting irritated.
Left hand से लिखी से तुम्हें convince.
Huh?
नहीं ये मेरे left hand से लिखी से.
Right hand से.
Left.
Left hand से. Left. Okay. तो ये क्या करूँ? Right hand से लिखो. मैं right hand में लिखो दिखाऊँ.
नहीं.
A B C D. Hiba, are you convinced that I wrote it in my right hand? Look at that.
Bro, can you believe that I wrote this in my left hand?
Guess what? So you want to master the art of writing on both the hands.
Yeah.
I'm also trying to do that with my right hand, and you're trying to do it with left hand. Do you know that?
I don't know that.
Yes, exactly.
Okay, the E's are not bad. Actually,
But my cursive is a bit bad. I mean, I'm gonna be honest.
Like, out of all of the days, I haven't still given myself a 5, but today can be good. Or I'm just feeling it.
Okay. I'll try these questions, but I wanna proceed further and faster.
You know the thing is that some of these are like super short, and then some of these are like super long.
Peel it. Cofactor. Okay, we are reaching to cofactors.
The G one is pretty hard, I would say.
Peel it. Peel it.
Like a C.
The minors and cofactors of the term.
Really hard. I don't know. Hard. Oh wait, where did it go? So packed. Okay, I cannot lose this. This is so important. Lose the book, it's okay. I mean, I don't want to lose it, but it's okay, but we cannot lose this. This is literally our like to-do list, and the thing that is.
I still don't know why I lost 1 subscriber here. I'm a bit confused. Like yesterday I had 115, now I have 114. I have no idea what happened. Did I do anything wrong or something? Or I think there was one person. Oh yeah, I had this channel very back on my day.
Okay,
So I don't know what's the use. I'll unsubscribe. I have no idea what happened. Maybe that's the case. You know, because I have done that most of the times. I would say because it's not useful for me anymore. That's why.
When I'm writing with my left hand, it feels like I'm writing with my right hand. I'm not even kidding you. I have become confused with it, but not like that. But I don't know. I feel like I still need the speed because, I'm sorry, this is not scare you. Like, I was writing, I just, like, so sad I didn't want to fix it. Yeah, but as I was saying, I think I need to increase my speed a bit because, I don't know, because normally I write really fast, so, why is there a huge gap? Okay, come on, you have to say, it's like, you have to say that I was writing with my right hand, come on. Come on, it has to convince you. It has to, okay? Okay. I want to do W. Sorry. It's kind of out of order, but I don't care. I want to do it. It's okay. You don't have to be perfect. No, this is my proof of not being perfect. Okay. Next. Oh, what happened? These W's are not good. I mean, if you still saw this, you'd be like, she
Okay.
probably wrote it with her right hand.
I think we can complete minors and cofactors faster.
Do you know the word?
We have almost 1 hour left, guys. Almost 1 hour left. What I mean is that we have 1 hour 6 minutes left in total. Then at sharp 5 o'clock, we start the test. What do you guys say?
Oh my goodness. Okay. Alright.
I'll also keep a timer of 1 hour. You know what? I'll just so you know what's actually going on. Maybe I'm not sure. Maybe not. Also, I just let's see. Let's see.
Sorry if I keep reading the book, but like, I'm trying to. I don't know when it's spacing, and like, I don't know what I'm doing.
Okay.
You know.
Oh yeah, I studied this
If you're
too. Log
studying, you
or
probably
log
like,
x
you're
m.
not
Let's
student.
unlog it
I
or
mean,
x
what's
m.
your
This one here will give 1 by n. This will give me.
I don't know.
No wait, there's a smaller here. It's not like this. It's like this. Log
Oh my god,
b
this
a log of a with base b into log
Oh
of
my
b
god.
with base a.
I think I need to
So here a is equal to 1. Yes.
Okay, put it at 3 because I count. Okay, yeah.
Kaddu practice paper.
J.
Practice paper. Determinant properties. I think I want to go through that whole quick idea so that I don't see any problems going on. Oh my god. I'm a bit scared too because these questions will not be easy at all. They will be a really good level.
Oh my god, it's so good. Am I losing myself? I don't know.
Let's take.
Like, come on now. It has to be like, if you first saw this, you will be like, wait, you wrote this to left hand, like, be surprised because it's like so surprising. I am myself is surprised. I mean, I guess that's no surprise. Oh wait.
Minor of
why
just
did
31831.
I changed? Oh, why did I do that? I don't know. I guess.
Oh no, that does not exist. Tutu, let's go for tutu. My pen ain't rang now. Bro, what? Bro, I think this pen lasted for only like how many days? Should be. Okay, wait. Today's Sunday, right? Let's say Wednesday. I think 5 days. The pen lasted for 5 days. That's very crazy, bro. 5 days is crazy. Wait, can we keep a goal of actually, using the pen in such a way that it just lasts for only 3 days? Can we keep a goal like that? It just shows the effort. That's it.
This is probably the longest time that has taken me to finish. Yeah.
Where's my cap though? I gotta check. Trap cap. Yeah. I'm gonna get a new pen. Wait. We'll try completing this in 3 days. What do you guys say? So today is how much? 26. It was 26th April. Today is Sunday. We'll try to complete it on Wednesday. At this time, 4 o'clock. Okay, Wednesday 4 o'clock. Let's go.
Hi. Hi. Okay, bye. I feel like my brother's gonna kill me, so yeah. But I don't care. Yeah.
Let's go. Yes, as I was saying, we got a new pen. Yeah, now it's 4 o'clock. Let's start it out. Okay. So, what I meant was, if I have a new pen and I completely use it until 3 days, it will show that I have practiced a lot. Why? Because if I just seriously waste my pen on drawings and all, which I'd never do, that will never happen, I guess. Maybe not. And when I actually like try to practice a lot, the pen may run out. So that's one thing I know. Let's go for M22. 22. Where is 22? This is the one. -2. So here we go.
Oh wait, I forgot.
1145. So my sister does drawing, but I do not. But I would likely say that I won't waste my time in much of scribbling and all stuff. The reason why is because I do not have much
It's
time.
not called wasting time, stupid.
It's called hobby, I know, but for me it's wasting time because I have to practice a lot of things.
Being an artist is actually a job that you can never even get.
So get one.
Try showing me you having a job getting a gas station worker. I bet you can't even get that.
Is that really bad? This is not a roast. That is very serious.
That is not even serious, bro.
So it's more serious then.
This is why you're so sensitive.
I'm not so sensitive. That's not good actually.
Look.
First of all, you should not say anything bad from your tongue. Not that bad. If you're joking, it's fine. But this bad thing, nah, I cannot. That is not good. Coming out from your tongue. That's not good. Really, I'm not joking. That's not
Did
good.
I tell that you were joking? No, right?
No, but still.
But
You always
still
take some things not serious.
Bro.
Yes.
Calling
Yes.
calling
Who should I
art
call?
as a waste is actually serious.
How can I
Because
call
that's-
waste? I
You
don't
literally called art as a waste of time.
see.
You're basically disrespecting all the artists that are making more money than you right now.
Okay, that's fine. I'm not saying that art is bad at all. It's a really good thing, but for me, it's actually wasting of time because I have to study. I have to do a lot of things. I have to like work out, man. Doing anything is like a waste of time for me. Even this thing could be the one. But yes, one thing is that this may not be the one again at the same time because this keeps me more focused sometimes. Trust me. Yeah, I have to do cofactors, right? Yeah. Let me just take this formula. Cij is equal to -1 I plus j mij. Hiba, write this word. Pneumono ultramicroscopic silicovolcanic in your right hand.
No.
in the last page or anywhere.
No.
Okay, write cat.
No.
Okay, so you hate cats.
Yes.
Exactly. Okay.
Because your name is Cat.
Oh, मुझे नहीं मालूम था. Oh wait, in fact मुझे मालूम ही रहना नहीं
Okay,
चाहिए.
I'm giving this a 5 out of 5. This is our first 5 out of 5.
Mij.
I'm so proud of myself.
Cij, that is cofactor is equal to minus 1 raised to I plus j into Mij. What do you guys say? Huh?
Because of that, I don't know. I guess.
Let's try to find out all the cofactors and minors in this. Let's try to find out all the minors in this. Hey! Listen. The concept of the math's name is known as minors. Don't think that I'm actually saying something really bad. I know there will be some people out there who will be feeling like, nah, that's really bad. That's really sus coming out of you. That is a mathematical concept that you study in determinants, okay? Don't think that it is actually something really bad. Okay? But the meaning of minor term here is to actually find out the product of this, and I don't know how to exactly explain, because it has its certain rules. That's why. And thank God nobody's looking at this part of the stream. And if they're looking at it, make sure you're watching this part too. I know there's some people who are like, nah, he said something really sus. I'm not gonna clip that. I'll clip that and I'll send it in some kind of social media platform like WhatsApp or anything. I know those people.
No. And then maybe
4. C11, right? That is minus 4. M12 minus 3. C12. Wait.
Okay. That's the worst patch ever. Well, okay. This is my
Plus 3.
So cute.
M13.
Well, I don't know. It's not that cute.
Finding minors.
Okay, and then
Again, I'm not being sus. Then we have cofactors 1, 3.
Day 27. Okay. See you on day 27. I am so proud of myself right now. This actually made me. I'm not even saying.
The minor of this determinant minus 3.
Stop.
It's maths.
Yeah, maths.
Determinants I'm studying determinants. You know what's the determinants?
Determine.
No. A compact form to express an expression. It's there in JEE mathematics. Very tough maths. Do you know that?
Now I know.
Yes. You do not have Aukat in this. I do not have Aukat in this. You have to gain Aukat. Get it. Do you know it?
Then why you haven't gained yet if we need to?
Because see, listen. It takes a amount of practice. It takes patience. It does not take to complete the whole syllabus. It takes 1 year or 2 years. So it's not like I'm gonna crack this in under 10 minutes. It's not gonna be like that. I'm not being tough, but I'm showing the truth.
Did I say that you're tough? No, right? So stop.
No, I know you may be feeling like it. I know that you're saying that always.
Stop being delulu.
What does that mean?
Delusional. You know 6'7". You don't know delulu?
Bro, it's because of the meme that is so famous, dude. Like, I sometimes hear it from small kids. What about this girl who knows Delulu? I have no idea what that meant. Hey, what's good? Yeah, that was the previous chat given by DIK. M13, right? This is 3 actually, and this one minus 1, 1, 3, 3. See. Oops, 2. Two. Oh, it's even. This one is odd. Alright, guys, since there is no one watching my live right now, and nobody's gonna be able to chat, I'll just ask the Google to, like, give me some random numbers for determinants. Give me 9 random numbers, in fact. 9 random numbers which are double digit, double or single digit numbers, should be small. What do you guys say? Should be small. Okay, this looks fine, right, guys? This is gonna be a good one. We'll use this determinant.
तुम्हारे viewers को भी बोलो.
Unmute हो. मैं share screen करके तो बोल रहा हूँ. 22, 9, 31. I'm actually gonna do column wise for now. 5, 18, 42. Okay, let's go. This is a pretty big number though. C11, C12, C13, C14. Sorry, it's not C14. C21, C22, C23, C2331, C32, C33. These are the cofactors. Now here M11 minus M12, M13 minus M14, M15 minus M16, M17 minus M18. Oh, actually, wait, I'm messing it up. Wait. Sorry. What am I doing? 21 is negative. 22 is even. So plus. 23 is odd. Negative. 231 is even. Plus. M32, right? So that's odd. And M33 is an even number, so plus. Okay. Plus. Alright. Not bad. Now we find the minors. That's it. Oh my god, I shouldn't have said that again. Find the whole thing. Oh, wait a minute, what? What just happened to the others? Yo, what happened here? Why got loaded like that? You know what, I'll switch this off. Let's go for it. M11, M12, M13, M21, M22, M23, M2. Let's go for this. 42, 9, minus 31, 18 is equal to minus 14, 42 minus 7, 18. That's a bit of bad. I actually give me really big numbers. Is equal to M13. M13 is this one, so 1431 minus 7, 9 is equal to. This one is minus M21, so 2242 minus 31, 5. Then M22, 22, my bad, M22, 342 Look, कौन सा?
अंकल प्लीज.
ओहो, वापस उठाना. C23 is this one minus this will be equal. This will be equal. Oh, assalamu alaikum. Assalamu alaikum. Lord Jawad. क्यों क्यों वो क्या भी है वो करने का और मेरा पेन कहाँ है?
तुम्हारा
अच्छा अच्छा सर, मुझे कि तुम्हारे पास ही है। अब पेन कैसे लगा? वेट, नो वे, इतना सब कुछ खत्म होगा हिबा?
क्या?
वो खाली 2-3 दिन को इस्तेमाल कर रहे हैं और इतना खत्म होगा तो मुझे नोटिस भी नहीं हो पाया, मैं इतना खत्म कर डाला मेरे को। मैं लिटरली क्वार्टर खत्म कर डाला नोटबुक का। I literally completed the quarter of my notebook. Like this is the one I'm using. Dang. That's why I like using registers, dude. Oh my god, I did not realize that. Anyways, let's continue. Minus 1 to 3, we're gonna take this down. 331 minus 22 7 plus M31. Where is M31? Plus M31 plus 1 7 22 18 minus 9 5 minus M32 32. Wait, I will mute my mic. There was a vacuum cleaner going on, I guess. You might have heard about it. इसका कर Oh yeah, some 11 strong concepts. Alpha plus beta plus gamma minus b by a. Alpha beta plus beta gamma plus alpha gamma c by a. Alpha beta gamma is equal to d by a. Is it minus d by a? Let's check. Alpha cos theta plus minus beta sine theta is equal to I don't remember what it was called. Alpha cos theta plus minus beta sine theta. What do you guys say? That will be range, and that range will be in what terms, guys? What do you say? What terms will the range in be? Will be? I would say the range in these terms will be uh, minus root of a square plus b square to root of a square plus b square. Let's check. And I think it's in closed bracket. So closed intervals. Whoa.
Yo, he, how are you doing? Glad to see you back. Thank you very much for joining my stream. And sorry for the loud background noise. There is a vacuum going on, vacuum cleaning going on actually. That's why. How are you happy with the 100 subs? I just want to say that. Are you happy with the 100 subs? Um, I'm good. Nice. That's really great to know. I'm really glad about that. How are you guys doing? This will be AXQ. I really recommend you joining in mobile streaming, like, on Friday, Saturday. I'm so grateful. OMGG, thank you, bro. You're welcome. I'm glad that I helped other person to get 100 subs. I'm just your 100 subscriber. That's it. That's it. उनको आवाज नहीं आ रहा वो mic में था।
Hi. Hi.
Okay, stop.
Hi.
Sorry, that was my sister. She just wanted to say hi. I'm not sure. Wait, I saw your post, and yeah, I was like, now, wow, you're really happy based on that. Go on, try to get more and more subs. You will get successful. There's so much great people in this world. I see. Thank you very much. There are many, many great people. Even though if there are many cruel people, there will be some great people. They'll make it neutralized. They'll never let the humanity lose. I'm not sure whether I'm a great person, but I will just say, yeah, I'm normal. Tahir, I think it's meant there. So, Hetso, you may. Anyways, bro, I was coming to say hi. It's just you, cause family business. You're a great person, bro. Thank you very much. I did not. I mean, for viewers' perspective, if that's the thing, then I'm really happy. But from me myself, I don't know. I just, I'm honestly, I don't like spreading any kind of negative or positive ego type. I just want to be normal. That's it, and try my best to make others happy if I can. Okay, if you want, you can go. If you want, you can stay. Depends on you. And thank you really very much for joining. I mean, I'm actually surprised. You can join on like Friday, Saturday because usually I do mobile streaming. You can also meet others there. But here there are very less people, who will watch my stream in these weekdays, huh? मोबाइल स्ट्रीमिंग मतलब फोन में बहुत सारे लोग आते तब. Everyone is great. Even there is great people. There might be a chance they have been through something. Yeah, that's true. I would say I take out my anger on people sometimes. I see. I get it. It's fine. But yeah, we should also learn how to control anger. Like I can understand the anger. I usually also take it on some people, especially on my sister. But yes, we should actually somehow learn to control the anger. And I actually, I'm capable of it, but no, I cannot do most of the time. So yeah, I partially pass, I partially fail sometimes, but yes, I know I can control my anger. Okay, yeah, area of triangle, properties now. We just have 15 minutes, dude. Whoa. 3, 1, -4. I will be using this notebook just, yeah, I try to learn, but sometimes it's too much, so I can't handle it. I know it's fine. There are certain limits for a person to actually burst out in anger. I can get it. I understand. And I hope you're doing great. I hope everyone is doing great in your family. And I wish for your success. Everyone will be wishing for your success. There will be some people to take you down, but don't let that ever stop you. You can do it. Okay. Also, I might be motivating. Sometimes I feel my motivation is trash, but trust me, even though if my motivation is trash, or even though if it is not trash, your discipline, if you try to master your discipline, you can do many things. It's way better than my motivation giving it to you. So yeah, trust me. Be whatever you want to be, and be that domain of that one certain aspect. You can do it. But I'm a person with a really high sense of humor, so when someone makes fun of me, I don't really care. It's like a joke, lol. I see. That's really good, actually. That's really, really good. Like, I actually, that is really good because, even though if someone makes fun of you and you don't really care, that is one thing you should actually really do. Because if you care about something which you shouldn't be doing, then you may be feeling tense based on that, and then you may be destroying the normal thing that you may be destroying the normal thing that you have been doing in the past. So yeah. Oh, you grew up with your three brothers. Oh, then you're a master in handling this, bro. I have one sister. I see. Yeah. Oh, I see. Okay. Okay. I think I did it correctly. Yes. It's actually the thing, um, having brother sister is actually fun, but at the same time very torturing and irritating. It gets tensed. Some people may not even want to have a brother or sister, but for me, I would say that I'm grateful for having my sister. Um, Even though my sister feels like that, I actually torture her a lot, but she does the same thing back to me. So yeah, she also keeps a comeback, and she might even do it worse than what I do usually do because she be it's me sometimes. But yes. Oh, I see. Nice. I got it. You're fine with it. Oh, okay. That's great. Sorry for this weird question, but I wanted to know whether you're living in which continent, like Asia, or you're living in Africa or Europe. Where do you live? Like, I have a small doubt. Or do you live in North America, South America, Australia? I'll just say that I live in Asia, Middle East, because I want to guess people's region. I want to see what all viewers of which region are actually watching my channel. Asia. I see. Nice. So sorry, I don't know how to spell. No, that's correct. That's correct. Asia is the correct spelling. That's the correct spelling. You spelled it correctly. Delta is equal to delta T. And also, by the way, what do you do for your channel? Like, what do you exactly do? Like, what do you make? What kind of shots you produce? Like, I have no idea actually. I just had a glimpse of your channel. Mm, I think you were doing some kind of one stuff I remember. Let me just check. Let's go to your channel and let me see. Okay, your name is Wolfie Waffles. Yes, there are some Among Us memes I could see. Okay, you watch anime, I guess. Yeah, okay, you watch One Piece. That's what I see. And you create. Oh, you're an artist. I see. I mainly do art and maybe editing. I see. Wait, um, I see. Wait, no. Go to shorts. Okay, here. Yes. Okay, wait a minute. Is it open? Wait, what's going on? How is it? Really? Go to shorts. Okay, I'm going to shorts. Why cannot. Yes, here we go. This is your channel. Uh, Someone said something. Sure, I will. Let's go. That is your channel. Nothing, nothing. I was just sharing your channel's, whole banner, your profile pic, and the whole description. Okay. Yeah. So you watch One Piece, you do art, and yes, also you do some artwork. I see. Okay. You know what? Actually, I cannot watch shorts right now because I don't want to steal your content or anything. It's your content, you know. I cannot do anything. Uh, this is my channel, so I don't want to steal anyone's content. I don't like doing that, actually, honestly. Sometimes I have to be really careful of that. This is your content. You're having the right of it. If it was for reacting, then it would be it would have been different. ये zero है. Nah, I give you permission, lol. Okay, you know what? If that's the case, then I will try to react your one shot. But because and actually I can react to only one shot because I have less time. And yes, my work is almost done, but then I have to do another thing. So yeah, I think it was called as Wolfie Waffles. Wolfie Waffles. That's what your name is, right? Wolfie Waffles. I see. This is the one. I like the profile pic. It looks good. Please subscribe. Yes, I am subscribed. You can see that. You have 102 subscribers. Let's go. I'm gonna take a look on this one. Wait, actually, 1 minute. Yeah. Maybe YouTube can put it down because of copyright. Yeah, it's because when I keep the sounds and others, it make take it down. But since you have given me the permission, I will try reacting to it. Is that fine? Or if you want, I won't. I will not watch it then. It depends on you. Can't see anything. What's going on? It wasn't supposed to be like that. Okay, here you go. Can't see anything. Lol. Okay, yeah. I'm not gonna play the sound because I think there is a font right there, so that is actually gonna be copyrighted. Uh, yeah. But this is your shot, so I'll try. Okay. Okay. Okay, that's good actually. That's really good. I like that editing. Nah, you can watch it. Okay. That's a really good editing. W edit. I like it. Okay. Properties. You know what? Let's go through this. Thank you. You're welcome. Yes, you're welcome. But sorry, I cannot play the sound because it could be copyrighted for sure. That's why the sound is copyrighted, but your video, since you allowed me, so it won't be taken down. I know for sure because YouTube will think it's in the form of a reaction video. That's why. It's not the best since I'm 12, but I'll try. Hee hee. I see. It's fine. I mean, bro, starting at 12 is actually great because that's some early timings of starting. You can also develop your art and other types of techniques or skills when you grow up. So that's really good. I can hear the sound through speaker. I'm wearing headphones. Oh, okay, okay. Oh, yeah, that's my headphones. I kept it near to this mic. I see. Barely though, so don't worry. I see. Thank you very much. I get it. Thank you very much. I did not notice that. I had no idea about it. Taking transpose of a determinant will have the same values. Property 2. I mean headphones lol. Oh, okay, okay. Got it. Addition of determinants. It's getting time almost, and yeah. Taking the common. Then what's the another property I have to look for? Let's go. After even number of changes, value of delta determinant remains same. Hmm. I see. Oh yeah, I forgot to take that. Okay. When is your exam again? There is no exam actually. I'm just working hard. I'm preparing for an exam though, but the exam is actually 1 year later. Yeah, you might be like, What? I'm preparing for an exam that is a year later." But yeah, the exam is no joke. It's not a school exam. It's really, really tough. I'm being honest. It's not an easy exam. It takes a lot of time. That exam is the third toughest exam in the world, and uh, it is containing the hardest level of mathematics, just like the Olympiads, and then it has good level of physics and chemistry. I'm also preparing for another content exam next year itself. That is not next year, right now, with biology, and yeah, I have to give that exam next year. I know, you may be shocked. I know you may be shocked. I mean, I'm not sure if I can call myself a genius because I would say that because of hard work, I tried my best to actually like, develop myself. But yes, I can say that I have the capabilities. But thank you for that, though. I think my stream was lagging for a while. I guess it was lagging. Thank you for the compliment, though. There is a small lag, I guess, that is going on. I allow you to call yourself a genius. Okay, okay. Okay, I would say then I'm a genius. Let's go. 2 by 2 determinants, addition of determinants. Oh, the sixth property. Yay! Stars. I see. Also, I wanted to say one thing. I'll be actually now locked in a bit for a while, like for 1 hour. It's sharp 5 o'clock. I have to start my work, like the main work I have to do right now. So I may not be like, responding to any chats. I'm extremely sorry because, this is a laptop stream. Usually recommend people to like join in mobile streaming because, like, on Friday and Saturday, because there are many, many people we can interact with. But right now, I will be not able to actually say anything because, right now it's 5 o'clock and I have to now be prepared. So yeah, I'm so sorry. I have to keep a timer and everything so that I have to be like, okay then, okay then. Okay, bye. He. Have fun. Have a great day or a night. I'm not sure what's the time there. I would say night. Anyways, bye, bro. Take care. Have a great day. Same to you. It's 5 p.m. for us. Oh, wait a minute. Oh, okay. So, wait, if it is 5 p.m. for us, then you may be living somewhere around near to us. That is actually a bit crazy because here it is also 5 p.m., 5 o'clock. I didn't know that. I just noticed that. Okay then, bro. I'm not sure. Wait, really? Yeah, it's 5 o'clock, meaning that you may be like, no way. I know, I know. Okay, man, I don't like saying this, but I'm actually curious. Since you said 5 o'clock, could you also say where you're living, like Middle East or where, like, I know I'm really sorry for this. I don't like saying these types of things, it's very personal. If I'm gonna say it, I live in Middle East. What about you? Like, do you live in Middle East or do you live in other regions? Because it's 5 o'clock here right now. Oh, so you live in Bahrain? I see. Guess what? I also live in Bahrain. I also live in Bahrain. Yeah. Like I also live in Bahrain if you don't know. You wanna know the location? The capital of the country? Manama. Okay, I'll just say Manama. I live in Manama. That's it. I'm not gonna go further. That's it. Yeah, it's getting too crazy. I don't wanna say it more. It's like revealing the address. I won't say it. Out of 8 billion people, I know, I know. It's a crazy miracle. You're really surprised. I know that for sure. Me too. I know. I know. I know. I got it. I've seen people who are living in Bahrain too, so yeah, don't worry. How do I prove that I'm living in Bahrain? Let me just show it to you. You see this? I think now you're convinced. If you don't know, trust me, I'm actually saying the truth. That's crazy, anyways, bro. Study hard. Yes, yes. As you say, as my viewers say, yes. At a time, at least one row column remain unchanged. I know. Okay, I'm so sorry. I gotta study now. Just wanted to say that it's time. I gotta go. Like not, I'm not gonna go anywhere. I'll just be here. I'll stay here. And yes, I'll soon meet you. If you want, you can come on Friday and Saturdays. Bye, 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 bye. Also, for those people who, okay, I'll just go pray and come back too. I gotta pray. Okay, and then I'll have to log in.
No way, bro. I'm 12 too. How? Wow, 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 wow. That's crazy actually, not gonna lie. We're from the same country and we are also the same age. Lost twin? I don't know. I don't know. Okay.
Sorry guys, I'm here. I forgot with the. Wait a minute. I'll just keep it like this. I'm gonna go for C. Electric charge of any system is. The minimum possible charge on a minimum possible charge on an object is C. Test to the. Please disturb me. Hito. Bala ko Please go away. I'm locked in here. Yo, horse. How are you doing, man? Oh, I think I actually caught him a bit.
Hi.
Wrong time. He went. He went.
Stupid.
Why are you calling him stupid?
I'm not calling him stupid. I'm calling you stupid.
Don't don't disturb.
You shut up. You shut up. What is your what is what is what is what is your even what even is your problem? Like hello girl. Hmm.
Stop it, bro. I'm getting irritated.
Bro, I'm getting irritated. Stop it, bro. I'm getting irritated. Oh my god, I'm so American. Oh my god, OMG. I'm so freaking American. So, lay girl, go for it. I am so American. I speak American English at my house. Oh my god. I am so American. SpongeBob laugh. Oh my god. Oh my god. Oh my god, so American. I am literally so American. I was born in America and I love America so much. Oh my god. My accent is American. I was never an Indian. I hate India. Hey girls.
I'm studying. Hiba may
I'm
touch the room.
studying. I'm
Hiba may touch
studying.
the room. Please
I
take care.
don't care. One, two, three, four, 5, 6, 7.
I'm extremely sorry for that, guys.
Sorry about that. I was supposed to show you guys my very nice sister. Oh my god.
Yo, hi there, bro. How are you doing? Long time no see. Sorry, I'm actually a bit busy. If you want to say anything, I'll try to say it later. I'm really sorry. I'm actually attending one test, as you can see. Please wait. Walaikum assalam. Alhamdulillah, sir. Alright, not bad, but I think I can do better for maths. I gotta practice more maths, J maths, or need maths because it's not need maths. What am I saying? I mean, need biology is doing fine. J maths, yes, I gotta do that for you. Like I'm very weak in it. So yeah, I think I have to take one day off practicing mathematics most of the time. Just only maths, pure mathematics. Rest all, yeah, we can check others for some time, other time. So we just completed our test. Let's go, hooray! I would say we got a pretty good score, but I can improve my maths. Man. So so I have a good news and a bad news. Good news is that I actually score very good marks, full marks in physics and chemistry. Which is actually good, but maths. Maths is one such thing I have to be taken care of. If I don't, that's what it will happen. So yeah, as you can see, we should not give up, guys. We have to like fully show our potential. I'm a bit scared based on that though. So today, what should we study next? Biology or physics? Physics will do KPP. What do you guys say? We'll do physics first or chemistry? Okay, you know what? Let's study chemistry. Then we'll move on to physics KPP. Then biology. And bro, I have to study mathematics, dude. Mathematics is one such thing. I have to make it really clear for myself. Bro, I swear I should take one day off for maths, just for mathematics. I really want one day off. But hey, let's go. Who's first on the leaderboard this time? Let's go, bro. We are doing the work here. We are doing. I like it though. I like it. I like it. So we'll do the test analysis. We'll take screenshot of those questions which we need. And also, I wanted to check. I'll remove most of my screenshots which I don't need. Once that's done, uh, I can take screenshots for the tests and questions I actually am very weak in. You know what? I gotta stop focus. No, maybe later. Chill, bro. Oh my god. Anyways, let's go. My leg, bro. My leg. So we'll prepare for mathematics. I would say that I have to practice more and more maths. If even though if I cannot do that question, I'll try practicing it. So it's fine. It's fine. This chapter is gonna end, and I have to fully focus nicely on mathematics. I'm not gonna lose a single focus on chemistry and physics, but yes, mathematics I have to, bro. I have to do it. I have to somehow lock in, bro. Wait a minute, guys. 1 minute. Yeah, I have to check the gallery view, right? Let me check. I will remove most of these screenshots so that I can actually like. What is this? Okay. Never mind. I have no idea what's going on. Yeah, these are some of these. Where can I find out my screenshots? I need the screenshots. Yeah, this one, right? So let's delete these types. I'm deleting these screenshots. As I don't need any of these. Yeah, this one. continuation, locked in. Why did I take screenshot? I'm still confused. Oh yeah, I remember now. Delete this one too. Delete these one, this 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 one. Okay, so I'm gonna delete all of these, and I have an idea. What I'm gonna do with these types of screenshots. Wait, there was another one. What was that? Oh, it's videos. Okay. Dang, guys. Dang, I swear. Like, there's so many of my messages in my groups. They post so many photos and videos. Okay, never mind. As I was saying, I have to improve my mathematics. That's what I got to know. My physics and chemistry is going great, I would say. I'm happy for that. And you know what? I still have to study chemistry and physics today, but I'm a bit scared about my maths, so I have to actually care for it nicely. So I have to take 1 day leave from school and focus fully on mathematics. And yes, tomorrow I'll study first physics because for school level, not the mean competitive exam one. And yes, today we'll be studying a lot of biology too. So as soon as we complete this, we'll focus on biology. All right. So what I'm gonna do is first I will revise a bit of chemistry. I think it should take half an hour, not more than that. I'll drink water and also come back. Then we'll do physics KPP, which should be very very fast done, or else it will take some time. And okay, wait a minute. you're ready, I'm hydrated. Let's go. I'm so sorry. I just wanted to drink water. I was feeling very dehydrated. Okay. Bro, where's the cap? Why is the cap vanishing again and again, bro? Like, what? Why is the cap moving from one place to another? Okay, Uh, okay, wait. Is there Robert W? Just 1 minute. I have a small doubt. Robert, Robert, are you there? What are you doing? Robert W has scored 1.3 points. Nice, Robert. Yo, Robert, do you go live? He streamed 58 minutes ago, only for 18 minutes. Why? It's fine. You guys can see it? No, you cannot. My bad. Robert, you Robert. Yes, here we are. Mashallah, bro has got a good look. Is there, is there hair in my? Is there hair in my mouth? No, I felt it like that. My bad. I felt it like that. My bad. My bad. My bad. My bad. My bad. My. Bro, I can really feel the hair. What's going on? Hello? Okay. So first of all, we'll move on with chemistry. Then physics, because chemistry there is one some topics I have to go to. Hey, Roberty, how are you doing? Let's like his video. 6 likes. You know what? He was live a while ago, so let me just check. Okay. We see some variety of viewers. Marisol Toga, hi. Wihan Agarwal vlog, hello. Boo, I cannot read that from here. What is that? Is that Abu? Okay, Abu Hussein. Okay, is that what you can? Or no, it could be Abu Hassan. I'm not sure. Abu Hussein or Hassan. Assalamu alaikum. Gloria Sklar said hi. Noel Bach 1014, hi. I liked Ashi Aluk. Nice. I don't know why this person gets a lot of Arabi viewers. Like, is it because of the region? Hi, Imab. Hi, hello, Bahrain. I'm Abu Bakr. You're my brother. Really? Let me. Wait a minute, guys. Let me just hear. Guys, can you hear it? 1 minute. Um, we have completed our test finally. Okay, here we go. Get out. Yeah.
Abu Bakr. Oh,
Yeah.
okay.
I like the background. So,
Nice.
I'm gonna increase the brightness a bit. Can you guys see it? Can you guys see the brightness a bit? 73. He's lagging a bit. You're my brother. Oh brother. It's brother.
Yeah, you're my brother. Nice to meet you. Are you like studying in a school right now, or like are you like have you finished school?
Hi Mab. Hi. Hello. Bahrain. Hi. I didn't expect his brother to come here. I had no idea. Is it? I think it's most probably his cousin. Cousin. Why is he happy?
Nice to meet you after so long. Hi.
Ahmedi. This guy's here. Yo, Robert. Yes, I knew it. Ahmedi, let's go.
Oh, hi, Ahmedi Gaming. Nice to meet you after so long.
Yo.
I think the last time we met was back in January. jogging stroller.
For anyone
Okay.
who doesn't know, he is an old viewer of this Robert W guy who used to live stream on January. But yeah, he's actually having. Why is he in that post? My bad. Misread. I'm pretty sure that you guys can read the comments here because
What you got?
it is not
Totality
like
Hire told me that
very
you're
visible.
waiting for me, so I went live. Told
What?
me that you're waiting for me, so I went. What you got? Totality Hire told me that you're waiting for me, so I went live.
Good evening. Sorry to disturb. Could you please send today's physics notes whenever you are available? I have some notes that I couldn't finish in class. All right. Who is this? Can you guys see the notification? Yes. For now, I'm not gonna actually do it right now, but I will. I will send the notes. Don't worry, bro. I can send it right now, but I feel like I'll send it at 8 o'clock. Okay, because that time I'll go to hall and then I'll have the access there easily. I know it feels very weird, and yeah, but I want to, the test just finished. Just 1 minute. I want to see this.
I
Hey.
casually see you like playing Roblox. Uh, and all. You know.
Yeah, yeah.
Yeah,
See,
like playing
who took my name?
Roblox.
Who took my name?
And all. I can me that you're waiting for me, so I went live. What you got? Totality Hire told me that you're waiting for me, so I went live.
Nah, I didn't say that he's funny. I said that
I
he's waiting
casually
for
see
me.
you like playing Roblox. Uh, and all. You know.
Yeah, yeah.
My hairstyle.
Oh man, if you
Also, I could say I lost interest in live streaming. You know, you're just sitting and I'm studying in that.
going home, what's it? Play the Roblox.
I quite lost interest in live streaming. I mean, it's no fun. I like making content. I want to make content, but I don't know what to make. I could like share my daily life, but I don't think people will watch it if I make content of myself.
Guys, what do you say? Does he say okay, okay? If you want this person to make content, I'll try to make tell him. I'll try to say it in direct on WhatsApp that you have to make a content. Try to make anything because, bro, trust me, this guy is even more has more time than me. Right now you may feel like, yeah, I have a lot of time. Of course not. I'm actually preparing for a competitive exam, and trust me, this is not easy. It takes a lot of time, a lot of practice, a lot of efforts, a lot of patience, a lot of time, and many many things. But I'm not saying that he has a lot very less work, but yes, he has he has enough time to actually make a content. He can make anything he wants. I can actually like discuss about it, and maybe if you want, I will try asking him to make one content. I'm pretty sure that people will watch him because I know that when I posted my videos, I had I've worked a lot in that, and I know that I got at least 100 views in that. Now of course those views are very less for you, but trust me, that's like having 100 people watching you, so still a big number for a number of people, right? Now, views could also be the number of times you watched, but
Anyways, maybe
still.
for the next what do you call for the next half hour, I'm not gonna reply to the chats because I have to watch my lecture and finish it. Because otherwise, if I keep looking at chats, I will keep getting distracted. So you know, I'm gonna just focus. Yeah.
6 minutes, 55, 84 minutes. Okay, okay. So he's logged in. He has the
There
stream.
are only three people. Anyways, where are you from?
How come only three
At
people
least
are
there are
there?
4 people in the chat because back then there were like 0 people. So this is something better than nothing. I'm grateful for that. Yeah.
What's his
And
name?
could yeah, yeah.
Yeah,
And I mean whenever you're live, I join. Do I know you before? Whenever you're live, I join.
I think it was edited.
Uh, I forgot who you are. My bad.
I think I know Billy Lover, but
25
yeah,
now.
But yeah,
That's sports.
what if
What was your original
actually
name? Like you might have changed your name. That's why I don't recognize you. Otherwise, I know my people.
okay,
Like
I'll go
Ahmedi,
through my name.
I know he was back then like a
Wait,
concurrent
Ahmadi, let's go.
chatter
Wait,
in my
wait,
stream, so I know him. But
oh.
you, I don't know.
Oh, okay. So I think. Oh, okay. Never mind. So it's a Billie Eilish fan. Okay, I get it.
Grand Fatima. I'm from Bahrain. How about you? I'm also from Bahrain.
OMG, it is a life so fast.
Literally, all of the people
I'll
here
be
are from
back.
Bahrain. So yeah.
Oh, I did not know that bro was actually there. Oh, okay.
Oh, I'm right.
He has little fans actually. I'm gonna be honest. He has a lot of people watching him now. Mashallah, Allah Mabarak. I also do have people watching me with the help of laptop streaming as well.
Sure, sure. It's fine. You can come whenever you want. Yeah, it's fine.
W Robert. So he actually, yeah, I told him to go live today because Ahmadi Gaming. I told him that he will be coming live, so that you guys can actually like talk about it. But yes, let's go. I'm happy that he was there. He is fully focused. I think he ends the stream here. He's stressed.
The recognition he deserves.
Bro, this stream has more viewers than my recent videos combined. Honestly, that's true.
Honestly, I'm just gonna not. I'm just gonna pause this stream for the
Oh,
next
the
30.
FPS, FPS,
How many minutes? 20,
FPS,
30. For the
FPS.
next 25 minutes
No,
because
no,
I'm getting distracted by reading
no,
the chat.
no,
So I'm
FPS,
just gonna be back in 25
FPS.
minutes. So it's 25 minutes because I'm getting distracted by reading the chat. So I'm just gonna be back in 25 minutes.
Wait, he said that he'll be back in 25 minutes. I didn't get it. What? So when did he stream again? It says that it was his latest stream, and here it is. Dang, dude. Why is this unlinked? What? Day infinity. What do you mean by that? So after day 60, he had a pause. I don't know why. Ooh. Sorry, guys. I know I was like, why am I doing this? Why are you wasting your time? Well, after ending the test, you can take small breaks and have a bit of fun. But yeah, that's what I wanted to do for a while. I just wanted to talk and let's see what others were doing. That's it. So yeah, Robert W. Thank you very much. And okay, did I take that back? Wait a minute. Okay. Let's go back. Is there anyone who said something to me? Anyone saying anything to me? Anything? Anything? No, nobody said anything to me. Like, yeah, I can see that this. Yeah, I said this. Yeah, I remember I commented this and I said to him like, are you coming to Robert W streams? He's actually doing it tomorrow, maybe. So yeah, I just helped other people reuniting so that nobody forgets him. Like I still remember those times in 2025 we were like live streaming together, studying in 11th standard, and now it has been like 5 to 6 months, which is pretty crazy. Right now we are gonna go live. We are gonna go not live again. I mean, we are gonna lock in Okay. And Robert W is still, there. I can actually tell him about it, and then he make content based on that. But it depends on him. It is the one he has the right of making anything. But yes, it also depends on the viewers. So if you want to say anything, you can ask Robert W. Try to force him if you want to make content. But yes, please don't force him that much because he's also a student who's studying, and he wants to focus just like me. And yeah, let's start. Let's not waste time. Okay, we're gonna start off with chemistry, and then we're gonna do physics practice paper, which is also known as KPP or Kaddu practice paper. For anyone who doesn't know what this Kaddu word means, it means pumpkin. I have no idea why my sir named it. It's actually for real. I'm not joking. For sure, I'm saying it. Okay. Um, Kaddu is means pumpkin in Hindi. For anyone who doesn't know, this is chemistry. Let's go. Yeah, we are practicing, okay? So let's start off. What we are gonna do is we are starting off with some interactions, okay? No, 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 wait. Pressure, the vapor pressure, yeah. Okay, vapor pressure. Here we go. So vapor pressure of pure liquid, molecules of liquid present in the bulk, bulk. Okay, what does that mean? Well, first of all, whenever we talk about vapor pressure, we should know that there will be two phases in this condition. Let's say you have a closed container in solutions. Okay, so at that time, when you're trying to heat the solution, you also notice that there are vapors forming up, and liquid is there too. It's not like liquid is fully evaporated. Liquid is also there, but also the gaseous state of that same substance is also there, which means the same solution, my bad, is there. So, what does that mean? We can say that these vapors are being formed and they're also creating some amount of pressure. Remember that. Pressure is also being created when these vapors are being formed. They actually they try to acquire more and more volume because their interactions are very less, and we're going to learn about it actually. So molecules of liquid present in the bulk and molecules of gaseous vapors present in the bulk. Okay. So what exactly happens? Let me just tell that. Uh, let's say that you're taking water. Okay. I don't have water. Again for the second time. And in water, you take below the surface. Okay, below the surface. Let's say that I do not have any kind of what is going on with my other headphones. It's actually vibrating. Okay. So, uh, to the let's say that we actually take some amount of water below the surface, okay, below the surface level, and once we take those and observe the particles, they're actually stable. They're not actually like uh, they're like stable. Okay, yeah, they have less energy and they are in equilibrium. Now, what does this actually mean? So, what you need to know is that at the surface level of water, these molecules gets heated up, just like evaporation is a surface phenomenon. So the surface molecules are first heated up and then they rise. Okay, let me give you a funny example. If you try to put a fire on a person's shirt, will he be running out of fear, or will he be like running for his life, like trying to find out water or trying to find out something that actually stops the combustion of the flame, or no, stops the running of the flame? Of course, yes, right? Or else he doesn't want to get burned alive. That's the thing. He'll scream very hard. I know this is a very brutal example, but this is very relatable to the particle stuff. Okay, so when you try to heat up a person with a fire there, putting a fire on his shirt. Ah, that's okay. That's not a good type of scream I did, but still, he runs and runs and runs. He goes fast. Yeah, that's a brutal example. I hope he's safe right now. I think he got some coolness. But if I'm being honest, what I would say is that what's going on? Okay, never mind. So yeah, what am I, bro? I swear this headphone, this left side is vibrating. guys hear? Okay, yes. So of course, this is the same case for the molecules. Like for the molecules also have a similar case. What exactly happens is that when you heat the molecules up, yeah, yes, they actually fly out. They will be released in the in the vapor form, so they are now in vapor state. And these vapor state exert pressure on the liquid surface, on the walls of the container, and this pressure that is exerted is known as the vapor pressure. Now vapor pressure is actually different for the solution a bit, like I'm gonna be honest. And when does vapor pressure occur, it actually should be having some conditions, like the in the process of the solution where the vapor pressure is there. You should have you should have the process of this solution from converting to vapor state as in the form of an equilibrium state, which means that rate of the condensation and rate of evaporation is equal. That is liquid in equilibrium to vapor. What am I saying? What am I yapping about? It means that if I'm actually converting some amount of liquid into gaseous state, there's some other amount of gaseous state that gets cooled down and gets converted into water, which means that they're like balancing out. This kind of thing is known as dynamic equilibrium. It's not static, which means that it is actually happening. The conversion is going on, the process is taking place, but overall the resultant reaction or the thing is that we are not getting to see any changes. That's it. So equilibrium is required, and yes, rate of evaporation is equal to rate of condensation in this case of equilibrium. Now here that's what you're gonna know
लिखने का प्रैक्टिस करे नहीं
chemistry.
लिखनी भी नहीं
Hmm.
तो अच्छा खुला रखो बेटा बोर्ड एग्जाम के लिए जी एग्जाम के तुम्हें काम आ गया होता
नहीं जेब में कहाँ से आता हूँ, वो जल्दी जल्दी लिखता हूँ बस, ऐसा रगड़ रगड़ को
तुम्हें नहीं ऐसा सही लिखना है बोर्ड एग्जाम के लिए भी लिखना ना
वो हूँ उसके लिए अलग प्रैक्टिस
प्लीज प्रैक्टिस करो
कर सकता हूँ ऐसे क्या फिर. My bad. Okay. Yeah. Kp pressure, equilibrium constant pressure is equal to the vapor pressure, right? If it is a saturated pressure, let's check. Let's check. Yes, I know my handwriting is a bit bad, but honestly, I feel like sometimes it doesn't matter that much in boats. But yes, I have to be really careful with that. Plus, I have to be, I don't think so. It will be worth it in J or need or J. I'm getting rage baited. I don't want to say the reason. I'm so sorry. I'm getting rage baited. I hope no one saw that, and I hope that nobody sees it in the future. This part. There are so many parts in the live stream which are really weird and dark, and I didn't. And you can only find them by watching the whole stream. Then you get to know. I think each and every stream has a secret. Maybe you may get to have some idea based on it, but the others you may not. There are some crazy moments though. I don't want this to be revealed in the this one. So I hope that it's kept safe. Yeah. Need and J, I'm coming for you. I'm coming for you, bro. I'm ready for it. I'm striving for it. I am not gonna give up. Jp is equal to vapor pressure, and if it is only in dynamic equilibrium, remember that. Let's just check. Uh, let's see the conditions for the vapor pressure. When does it happen? When does the vapor pressure take place? What are all the conditions? I want to know that. take place during when it is in equilibrium should be heated about. Oh, it's a charge. Okay. So it only takes place during equilibrium, I believe. But it's only taken for the condition of a closed container. But I think there are many conditions where you're just checking closed containers. In a closed container, that's what it says. And Regina came and then said hi. I'm really sorry for that. I did not respond. But I was like, writing the test, so I was pretty busy at that time.
I was gonna sleep like that, huh?
Yeah, this is hard. I'm not gonna say anything. I'm just gonna try not to sleep, dude. So ionic force, ion dipole. Then we got before that dipole. No, after dipole and before ion dipole. Hydrogen bonding. Before dipole is induced dipole and van der Waals forces. For the polar compounds like forces of attraction, it's more than the forces of attraction of non-polar compounds and such ideas. Non-polar compounds, the forces of attraction is mainly like van der Waals forces. Some of them may even undergo dipole-induced dipole with the other polar molecules. I don't know, man. I'm getting so much sleepiness, which I should avoid. I mean, what I meant was I'm actually sleeping very less. Was there a lag? I guess maybe there was a slight internet connection issue. I guess. Oh, there was one person watching me. I guess. Let me just check the formulas. Formulas here. Oh, I'm just joking. I'm not doing that. What am I doing? Guys, are we cooking? You know what? I gotta go faster, but I feel very stressed out. I won't give up though. Okay. So vapor pressure of a solution of non-volatile solute in a volatile solvent. We need to know that in volatile, the more volatile the component of the solution will be, the more easily the molecules will escape from their liquid phase, from the surface to and enter into the physical state of vapor phase, and that's how we can determine it through the help of volatile solvent and non-volatile solute. So how is this done? First of all, we need to know that at heating at a specific temperature of T, the okay, let's say, you know what, there's a vapor liquid. Okay, you have a pure liquid. You did not put any solution in it. Okay, there you have pure water. Let's say you have heated it at the temperature T, and some vapor molecules are also formed. The vapor that they're exerting is in the form of a pressure, vapor pressure, and we call that pressure as P A, let's say, and then it also has its own partial pressure. So let's say, but we usually call it as vapor pressure. So P naught A, okay, P naught A, and my bad, yeah. So calling it as P naught A, and when once we add the solution, once we add it, what will happen? You will have solute. You will have the solute being non-volatile, so solute will not actually vaporize, but the solvent does, right? The solvent will vaporize, and therefore the vapors that are exerting force will be solvent, of course. So we can say that the vapor pressure of the solution will be different this time, because it's a bit lower this time, because those non-volatile solute is blocking their surface area. They're blocking their some amount of places where they are supposed to be releasing in the form of vapors. So that's not happening, right? Therefore, we can just say that this vapor pressure of solution that is formed is having lower vapor pressure than that of the pure partial pressure, or the vapor pressure of the pure liquid solvent. And this type of pressure, that we call it as lowering of pressure, vapor pressure, or relative lowering of vapor pressure. And this depends on the number of molecules of solvent and solute. Okay, mainly it's solute, not solvent. Solute. Let's say mainly solute. Solvent is also fine. It's correct, but solute fits more better. And remember that this is a colligative property. So the colligative property has this type of property, of course. So vapor pressure of solution is equal to PS. Uh, who called me nerd? Who called me nerd, guys? Did you all buy books like Practical and Diary and all? Where are y'all? Oh yeah, it is necessary to buy. No idea. What is going on? Okay, I actually thought that they were talking about me. Sometimes there are some people who call me nerd sometimes. Vapor pressure of solution is okay. Why is it glitching? The voice. I feel like the voice is glitching for a while. Like, do you sense some more of voice glitching? Is there latency? Oh, yeah. Okay, never mind. I was just checking the latency of the sound. Plus, we won't say voice is glitching. It visually things which are affected, and we see them, and there's something going wrong visually. That's glitched. The sound being glitched is actually not the thing we should say. My bad. Instead, we would say corrupted sound or breaking down of a sound or something you can say. I'm not sure. Just like how you say optical illusions for sound, you call it as auditory illusions. Partial pressure of vapor. Oh, it's called the law states that the partial vapor pressure. Okay, so the partial vapor pressure of each component of the solution is directly proportional to the mole fraction of it, and the constant that we're going to use is called as vapor pressure of the pure solvent that it was used to be. It's a special case of Henry's law. If you don't know, pressure is also directly proportional to solubility, and from there we can also derive that pressure is directly proportional to the mole fraction. And there, the pressure being directly proportional to mole fraction, to actually make it equal, we use the constant of proportionality, Henry's constant, which is kH. Here's the same thing. You got pressure in the form of vapor pressure here, and There the mole fraction is mole fraction, and the KH is acting as, P naught, as the pressure constant, partial pressure constant here. So it's actually a constant. Remember that. So that's how Rolle's law is followed, and Rolle's law is followed by some types of solutions. Not all solutions obeys Rolle's law. They may go and vary based on what type of forces of attractions they have it between them, and those are called as, positive deviated solutions, or sorry, negatively deviated solutions. Those solutions are coming under those non-ideal solutions. That's all I can say. Vapor pressure of a solution of a volatile solute in a volatile solvent where both are miscible. This is a good case where attraction and B attraction are equal to AB attraction. This is the same case where we would say that ideal solutions are followed, and the PT is equal to PA plus PB, where PT is equal to P naught A chi A plus P naught B chi B. In the previous case, we actually took a volatile non-volatile solute and a volatile liquid, where the volatile liquid was only considered, and there we took PS is equal to P naught. Uh, chi, and here we are going to take it as the total vapor pressure of the solution. Remember, ideal solutions are those solutions having equal same interaction forces after and before the solutions were mixed. So, which means that the components which were separated had the same force of attraction to that after, which is when compared to the aftermath of the, mixing of these two components forming a solution. Same type of forces of attraction was shown. Now PT, which means not PT period, not physical education period, it means pressure being equal to PA plus PB. Now this PA plus PB are the vapor pressures of the components, okay, which is P naught and P naught B, to be precisely said. So P naught A chi A plus P naught B chi B. That's what we're gonna usually find out in the questions. So PT is equal to P naught A chi A plus P naught B chi B. Now let's try to practice this for a while, because we need to have some really good ideas. Guys, we have to do a bit faster this time, because I feel like I have to do next is physics. And if I don't get time, I won't enough for time for bio, then I'm cooked. We have to also do a bit of 11th biology before we, like, first we'll do 12th biology covering reproductive health for like practicing the questions, and then we're gonna do, the genetics part for 1 hour. Then, yeah, that's how we're gonna do it. 1 minute. So 3 hours, 13 minutes. Oh, that's not good. Genetics is a big chapter, guys. It's very big. It's a big chapter, genetics. Like, I think it will take a lot of time. It'll take me 5 days to complete the lecture of one chapter. If I actually do it consistently, and then 5 days meaning that I have to like practice questions. I have to like revise it. So 5 threes of 15. 15 days for that one chapter, guys. The reason why I'm taking 15 days is because I'm not only studying biology every day. I'm studying many subjects, even the school ones. So I'm actually studying biology consistently. P naught vapor pressure of solvent, PS vapor pressure of solution, P naught chi is a, you know the vapor pressure of solvent. P naught chi solute. Ah, what was I doing? What am I doing? Am I dumb? Yes, kind of, you can say. Sucrose, screen sugar, C12 is 2211. C12 has 22O11. C12 has 22O11. C12 has 22O11. Sucrose is C12 has 22O11. Glucose is C6 has 12O6. Sucrose is C12 has 22O11. Wait, what is the chemical formula of sugar then? I'm so confused actually. I used to remember it long back ago, but I don't know when. What is the chemical? Is it sucrose itself? Is it like C12 has 2211? Chemical formula of sugar. Sugar. I'm pretty sure it's sucrose. 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 Oh, okay. Sugar is sucrose itself. हाँ खा तो बाद में अभी टाइम थोड़ा देर वाले 8:30 आऊँ sucrose. Okay, thank you for the information. P naught minus PS by PS. Oh, this is one thing I forgot about. Okay. Now we have to calculate the composition of the vapor phase, that is the mole fractions of the vapors. Okay, guys, we are really close in completing the whole part of what we have learned till now. You have to speed run now, okay? So before 8 o'clock, you'll try and then we have to complete this. We're gonna get 3 hours of biology. Is that enough? I don't think so, because I want to also go for other chapters, in bio. I'm not sure, but if I get some more time, maybe I can complete one. No, I don't think so. It's fine. Let's go fast then. We will not waste time. Let's go faster. Okay. So let's go fast. PA by PB. P naught A chi A by P naught B chi B. What? No, P naught A, P naught A chi A. Okay. And that's how I can actually write it as this. P naught A greater than P naught B, volatile of A solution, or sorry, component A is more volatile than component B. So easily we can use the distillation process and separate them at a temperature T, where we assume that A gets converted into vapor state. Most of these will form more concentration of A, and by the continuous process of this distillation process, we get maximum amount of concentration of A in n amount of times which we are assuming. So in this case, ya1 by 1 minus ya1 is equal to p naught a chi p naught b into chi a1 divided by chi b1. Mole fraction of A and mole fraction of A in liquid phase of container 1 and liquid phase of container 1. We have to check this out. And chi A2, okay, let's say that. 1 minute. Ouch. Now, after distillation process and after condensation, okay, we are actually now bringing it in such a case where the concentration of A now in terms of mole fraction is more. So, uh, chi A2 is equal to ya1, and you know, chi B2 is equal to yb1. That's what I can say, guys. W. All right. Okay. PA2. So YA2 by 1 minus YA2 is equal to P naught A by P naught B the whole square chi A1 minus by 1 minus chi A1. Didn't I make this whole process work? What? Yeah, this is the one. Case of evaporation. Case of condensation. Finally, guys, we're completing chemistry revision. We are doing it. We are doing great, guys. Don't give up. And then we have to practice physics. I see. Formulas plus concepts, reactions, exceptions, NCRT lines plus diagrams. How am I gonna do that though? Short notes. Do I have that? I mean, okay, yeah, I'll check. I'll check. Okay. Let's check. I see. Then open notes and fill gaps. Practice MCQs. Okay. Okay, let's check. Let's check if I can do that. Okay, so that's what I'm gonna do. How's my accuracy 100%? So we gotta lock in on maths. That's what I know for sure. Like there was one thing that the test will get over on 7:50, so I had to check what was going on. That's it. And I was also checking for revision techniques. If we are using it, then let's try. Okay. Oh, okay, okay. So let's say composition of first drop of liquid form. If in the case of condensation there are vapors, and when we try to lower the pressure, I know that there will be no, no, we are actually applying pressure. Yes, we are applying pressure. What am I saying? We are actually applying lower pressure. Oh my god. I'm gonna sit on a chair for. I'll sit on a chair for a while. It's my legs are paining for a while. Like I don't know why. I'm so sorry, guys. Oh. Yeah, it's charging me. It's charging. Composition of first drop of liquid form. Uh, minute. I'll also go through all the questions so that I don't forget. Then we have mixture of two volatile liquids, both are immiscible, which means they don't mix. You have to check that on. रुको वो
बंद करो Sure.
1 minute.
Repeat it.
Hmm. Sorry guys, I had to change the background settings, I had to change it. Like the background, yeah, that background was getting, was there for a long time. I had to change it. I felt like changing the background. Oh, let's go. 7 hours long stream. For that, 1 minute, I might have to send the notes. Like one of my friends asked me. So wait a minute, Vice. We have already reached to our destination, so wait. Okay, I sent the notes. We can continue now. Wait a minute, I'll just keep it back. Okay, what did Regina say? Let me just say. Regina had earlier said hi, and then I said, I'm really busy. So I said, okay, okay. Battery, yes. Battery, let's go. Temperature 50 degrees Celsius, 70 degrees Celsius, 95 degrees Celsius, 98 degrees Celsius, zero point 0.5 ATM, 0.6 ATM, 0.7 ATM, to 0.88 ATM, to 0.81 ATM, zero point 0.1. Let's go. 1 minute. Ideal solutions which follow the Raoult's law entirely, such that the pressure, the value that we get is equal, that the interactions of AA and the interactions of BB is equal to interactions of AB. Then what can say about that? The graph, that if we take a graph of this ideal solution, we plot P naught B, P naught A, and then the x-axis representing mole fraction of the solvent, and then the y-axis representing the what it is, yeah, total pressure, and pt is equal to p dot a plus chi a plus pt is equal to p dot a chi a plus p dot b chi b. Then what else, yeah, in terms of the enthalpy mixing of the enthalpy is zero, then the volume mixing is also zero, and but entropy is actually change in entropy is greater than zero, and change in Gibbs-Free energy is lesser than zero. The reason why we are having entropy greater than zero is because even though ideal solutions have different components in having the same amount, type of interactions, the molecules will be different. The size of the molecules may be different, right? The atoms may have different sizes. So based on that concept, when they try to bond with others, what happens is that they form an unsymmetrical bond. This unsymmetrical bond is, let's say, in component A, there are two atoms forming a molecule, let's say H2. So same AA molecules, okay, same size, they are symmetric. So they don't cause many randomness. Same for the case of B, B molecule. It could be anything. The size of that atoms and the molecules is different. Then for different components, but same components will have same type of sizes for the molecules, like so that's what it is. So when we are actually making a solution, we have different components mixed, so different molecules bond together with the same amount of interactions with the previous ones, like AA and PP. And then what else happens? Then we get to know that they form an unsymmetrical bond. This unsymmetrical bond leads to more random of more degree of randomness, and therefore entropy is positive. But if entropy is positive, it also signifies that the reaction is spontaneous. The mixture of the reaction is actually spontaneous, and this spontaneity of the reaction is feasible. This feasible reaction leads to showing that Gibbs free energy or free energy is negative. So Gibbs free energy, that's change in Gibbs free energy, is negative, less than zero. So that's the solution. Examples of ideal solution: um, N-heptane and hexane, benzene plus toluene. What else? What else? What else? There are many, many more types. Ethyl bromide, ethyl chloride, and chlorobenzene, bromobenzene, hexane, heptane. Yeah, I'm trying to do as fast as possible. Non-ideal solutions which do not obey the Rawls law is known as non-ideal solutions. There are two types: positive deviated solutions and negative deviated solutions. In positive deviation, the vapor pressure is expected is more than that of the expected vapor pressure calculated from Rawls law. So therefore, since there is more vapor pressure in this type of solution, lesser will be the boiling point. Since there is lesser in the boiling point, also temperature will be more, and the intermolecular force of attraction for when the solution is formed is lesser than that of the components. So that's one thing you can say. And yeah, that's the main reason for the positive and negative deviated solutions. And yeah, that's pretty much how we can actually answer. Delta H mix is greater than zero. Delta H mix is actually greater than zero. Why? Because you need stronger for component A and component B, you need more energy to break the bonds, and once the to absorb and let the bonds be broken. And once they release the energy, less amount of energy is released than that of the energy being absorbed. So the bonds are still broken down because the attraction force about the for the solutions are less. So based on that, and based on that type of cases, we can just say that, oh yeah, that's how it is, dude. Like, how is it off? How can we say that is it off? Like, my bad. That oh, wait a minute, this is how it is. You're actually getting positive deviation, which means that delta V mix is actually greater than zero, because energy, yeah, okay, energy also, right? Energy is actually being more absorbed, so it's delta H mix will be positive. Enthalpy is positive. Endothermic process, energy is absorbed. And then um, talking about the case of the volume mixing and the volume mixing case, here the volume is actually increasing. Why? Because the interaction is lesser, the molecules will have more intermolecular space, and that intermolecular space leads to more volume, and that's how it is done. So yeah, and then spontaneity of that reaction is still there, so delta G is negative, delta S is positive in all the cases. And they're talking about the graph, it is a curve like this, there is a curve like this. Then we got the negative deviated solutions. Negative deviated solutions, we got those cases where you have to consider, okay, wait, examples. C2H5OH plus cyclohexane. C2H5OH C6H12, C2H5OH H3CO CH3. CCl4 is not going under dipole, it's going under van der Waals forces. C2H5OH is H bonding, positive. dipole, 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 dipole. Stronger dipole. It's actually forming hydrogen bond. My bad. Bro, come on, be careful. And some days there will be one viewer watching me, and somehow something's bad gonna happen. That's for sure, I feel. I don't know why. I have a great feeling like that. Someday there is a viewer watching me, and right now I'm safe. Nobody's watching me. I'm safe uh, in these circumstances, but bro, someday for sure. I'm cooked that time. Imagine those streamers who have like many viewers watching them every time, like every second of that stream, and they can actually find out many things and many small details. That's what scares me. They might even find this part of clip. Finally, we have completed physics part. Sorry, chemistry part. Doesn't evaporate. Oh my god, HCl plus H2O. I'm actually tired. Okay, it's fine, it's fine, it's fine. One minute. Please, please do not disturb. Let's practice some really tough level questions in physics. Guys, please wait a minute, okay? So, what I'm gonna do now is I'll eat and come back, and then once I eat and come back, I'll start starting again, okay? Now I have to eat, then I'll do biology, alright? Let's go. Forgot to mention that I was muted and I lost focus, but yeah, we are keeping the pace. I feel like I still have to do some basic physics. I don't know, man. I feel like I have less time for biology. This happens every day. I get very less time to study other things. I think it's my mistake though. But still, we are not gonna give up. Okay. Like, bro, these things, these questions are like J advanced or something. I have no idea. These questions are really crazy. Or there should be very tough level questions of J mains. Ain't no way that these are really that easy. Like, have a look at this. These are not easy at all, dude. These are not easy. These questions are really good level. I don't know how to express those physics questions, but they're really tough questions. I did solve some of them, but that is really tough. It will take some time to like solve others. Okay. Q, Q. This is tension. T is equal to mg, and this is also tension. That is T is equal to F. So F is equal to mg. Yeah. ये डाल F is equal to 2 mg now. Now we have the idea about the mass, that is 0.9 into 10 into 2. It's equal to K is 9 into 10 raised to 9 Q square divided by 3 square. You have to find us in microcoulombs, by the way. Zero, zero, finally, guys, we have done questions of the second chapter of biology, and we are moving on to the third chapter of bio, that is genetics. And I'm happy actually because we are progressing now. We are actually putting a lot of progress in biology, and yes, I need to also progress on mathematics. And believe it or not, tomorrow I have to go for physics again because tomorrow is there is physics class. So yeah, that's pretty impressive, right? But that's not also good because mathematics is very important. But let's see, man. I just don't know how I'm gonna manage mathematics. It's very important. Anyways, let's move on. I have to go to wait before that. I have to keep up my streak, okay? I'll come back, okay? I have to go to toilet. It's urgent, actually. I'm really, really sorry. Till then, this lecture will be playing off. Let's go. Yo, Horse XD. How are you doing, Horse? Nice to meet you. I saw your previous messages. I'm so sorry that I didn't respond. I was locked in. I was actually attempting a test. Wait a minute.
अभी इनके बारे में बात करते हैं कि इन्होंने एक्सपेरिमेंट क्या किया इन द मिड 19th सेंचुरी यानी 1800 से 1900 के बीच। तो 1856 से लेकर 1863 तक यानी इन 7 सालों में इन्होंने अपने
1856,
एक्सपेरिमेंट किए।
1963.
और जब 1863 में इनके एक्सपेरिमेंट पूरे हो चुके थे 1865 में यानी एक्सपेरिमेंट पूरे होने के 2 साल बाद ही इन्होंने अपने पेपर्स को रिसर्च को पब्लिश कर दिया। इन 7 सालों में से यानी कि 1856 से 1863 में से लगभग 4 साल का टाइम तो इनको प्योर लाइन बनाने में ही लग गया था। प्योर लाइन मतलब नाम से समझिए, प्योर लाइंस में प्योर शब्द आ रहा है। यानी अगर कोई मटर टॉल है तो वो प्योर टॉल होनी चाहिए, कैपिटल टी कैपिटल टी, कैपिटल टी स्मॉल टी नहीं। आपको पता है कि कैपिटल टी स्मॉल टी इज आल्सो टॉल, कैपिटल टी इज आल्सो टॉल। प्योर टॉल मतलब कैपिटल टी कैपिटल टी। कैपिटल वी में भी वायलेट फ्लावर है, कैपिटल वी स्मॉल वी में भी वायलेट फ्लावर है, लेकिन कैपिटल वी को ही आप क्या बोलेंगे, प्योर वायलेट फ्लावर बोलेंगे। तो इन्होंने प्योर लाइंस बनाई, प्योर लाइंस बनाई। 3-4 साल लग के तो इन्होंने प्योर लाइंस ही तैयार की। इनके एक्सपेरिमेंट्स को हाइब्रिडाइजेशन एक्सपेरिमेंट्स कहा गया क्योंकि इन्होंने मटर की अलग अलग हाइब्रिड्स तैयार की। गार्डन पी को यानी पाइसम सताइवम को इन्होंने यूज किया और इन्होंने दिए लॉज ऑफ इनहेरिटेंस। इनहेरिटेंस मतलब पेरेंट्स से अगली जनरेशन में कैरेक्टर्स का जाना। और इनके लॉज जो है वो मेंडल साहब ने दिए, यानी मेंडल साहब ने कुछ ऐसे बेसिकली रूल्स बनाए अपने एक्सपेरिमेंट्स के हिसाब से कि भैया पेरेंट्स से जो अगली जनरेशन है, जो प्रोजेनी है, उसमें इस प्रकार से इनहेरिटेंस हो रही होती है। इन्होंने कुछ चीजें नोटिस की कि पेरेंट्स से जब इंफॉर्मेशन प्रोजेनी में जा रही है तो किस तरीके से जा रही है, किस ट्रैक से जा रही है, और उसको नहीं है उसमें इस प्रकार से इनहेरिटेंस हो रही होती है। इन्होंने कुछ चीजें नोटिस की कि पेरेंट्स से जब इंफॉर्मेशन प्रोजेनी में जा रही है तो किस तरीके से जा रही है, किस ट्रैक से जा रही है, और उसको इन्होंने लॉज में कन्वर्ट किया। So they are general rules backed by research, not only unsubstantiated ideas. Unsubstantiated ideas मतलब कुछ भी नहीं बोल दिया इन्होंने, रैंडम नहीं बात कर दी। अनसब्सटेंशिएटेड मतलब कोई ऐसी चीज जिसके पीछे सब्सटेंस ना हो, जिसके पीछे तथ्य ना हो, ऐसी कोई बात इन्होंने नहीं की। इन्होंने वही रूल्स दिए जो कि बैक्ड बाय रिसर्च थे, यानी जो रिसर्च द्वारा प्रूव थे। यानी अनसब्सटेंशिएटेड आइडियाज नहीं थे इनके, हवाबाजी नहीं थी, बल्कि इन्होंने कुछ रूल्स दिए, ठोस रूल्स दिए, जिसके लिए पहले इन्होंने रिसर्च की, अपना डेटा निकाला और तब जाके सारे के सारे रूल्स दुनिया के सामने रखे। पहली बार इन्होंने ऐसा किया कि बायोलॉजी में मैथ को घुसाया जाए, बायोलॉजी में स्टैटिस्टिक्स को घुसाया जाए, और इसीलिए इनको एक नई फील्ड आती हुई दिखाई दी बायोलॉजी की, जिसे जेनेटिक्स कहा गया, जहां पर मैथ का भी इंटीग्रेशन हो जाता है। एंड मेंडल साहब सक्सेसफुल क्यों हुए? क्योंकि इन्होंने मटर को चुना। मटर का लाइफ स्पैन काफी छोटा होता है, 2-3 महीने में ही
ये अपने बच्चे पैदा कर देते हैं, नेक्स्ट जनरेशन बना लेते हैं, तो आप कई जनरेशन तैयार कर सकते हो। तो बहुत कम टाइम में बहुत ज्यादा डेटा आपके पास आ जाता है, और जितना ज्यादा डेटा आपके पास होता है उतनी ही क्रेडिबल आपकी रिसर्च मानी जाती है। और इन्होंने प्योर लाइन्स भी बनाई जिससे इनका डेटा और बेहतर तरीके से आपको आता हुआ दिखाई दिया। तो ये प्योर लाइन्स क्या है, इनके बारे में भी थोड़ा सा हम लोग समझ लेते हैं। व्हाट इज अ प्योर लाइन? प्योर लाइन मतलब एक ऐसा प्लांट जो कि ट्रू ब्रीडिंग कर रहा हो। ट्रू ब्रीडिंग कर रहा हो मतलब फॉर एग्जाम्पल अगर समझ लीजिए एक प्लांट टॉल है, तो कैपिटल टी स्मॉल टी को भी टॉल बोलते हैं, कैपिटल टी को भी टॉल बोलते हैं, लेकिन यही आपकी प्योर लाइन है। कैपिटल टी प्योर टॉल है, छोटे टी का नामो निशान नहीं। और छोटा टी भी प्योर ड्वार्फ है, बड़े टी का नामो निशान नहीं है। बड़ा टी हो जाएगा तो भैया प्लांट ड्वार्फ रहेगा ही नहीं, टॉल हो जाएगा। तो छोटा टी प्योर ड्वार्फ, बड़ा टी प्योर टॉल। तो आपने यहाँ पर देखिए कुछ एग्जांपल्स देख रखे हैं, इनमें से हमें प्योर लाइन बतानी है। कैपिटल टी दोनों सेम है, प्योर है। कैपिटल वी स्मॉल वी प्योर नहीं है। कैपिटल वी प्योर है। स्मॉल वाई प्योर है। कैपिटल वाई प्योर है। कैपिटल वाई स्मॉल वाई डिफरेंट हो गए, प्योर नहीं। स्मॉल वी प्योर है। स्मॉल टी प्योर है। चाहे आपका प्योर डोमिनेंट हो चाहे प्योर रिसेसिव हो, दोनों अलील एक जैसे होने चाहिए। इसे आप क्या कहेंगे? प्योर लाइन कहेंगे। इसे आप ट्रू ब्रीडिंग प्लांट कहेंगे कि ये भैया है आपका प्योर टॉल, ये आपका प्योर वायलेट, प्योर आपका ग्रीन, प्योर येलो, प्योर वाइट, प्योर ड्वार्फ। ऐसे प्योर शब्द का आप इस्तेमाल कर सकते हैं। समझ लीजिए आपके मेंडल साहब ने मटर लिया, मेल और फीमेल, ये भी आपका प्योर टॉल। यहाँ पे कैपिटल टी ही आएंगे गैमेट में, बच्चा भी बना कैपिटल टी। इसका फिर कैपिटल टी से मर्जर कराया, बच्चा फिर बना कैपिटल टी। इसका फिर कैपिटल टी से मर्जर कराया, बच्चा फिर बना कैपिटल टी। फिर कैपिटल टी से मर्जर कराया, बच्चा फिर बना कैपिटल टी। यानी मेरे भाई इस बच्चे ने अपनी पिछली कई जनरेशन से स्मॉल टी का मुंह तक नहीं देखा है, सिर्फ कैपिटल टी की ही शक्ल देखी है। तो इसमें स्मॉल टी आने का कोई चांस नहीं है। जब आप कैपिटल टी को ही सेवरल जनरेशन तक इनब्रीड कराते रहेंगे, क्योंकि जो मटर का पौधा है वो बायसेक्सुअल है। तो समझ लीजिए एक मटर है प्योर टॉल, एकदम प्योर टॉल, कैपिटल टी। आप क्या करो, उसी का जो पॉलन है लेकर के उसी की स्टिग्मा पे डस्ट करा दो, तो जो बच्चा बनेगा वो भी प्योर टॉल बनेगा। दोनों गैमेट में कैपिटल टी ही है। फिर उसकी फिर सेल्फिंग करा दो, यानी सेल्फ पॉलिनेशन करा दो, फिर आपका कैपिटल टी बन जाएगा। फिर पॉलिनेशन करा दो सेल्फ वाली, कैपिटल टी बन जाएगा। फिर सेल्फ पॉलिनेशन करा दो, इन ब्रीडिंग करा रहे हो, सेम ही प्लांट के दोनों गैमेट्स को आप इस्तेमाल कर रहे हो, इन ब्रीडिंग कराते जा रहे हो, तो स्मॉल टी आने का कोई नामो निशान ही नहीं है, सिर्फ कैपिटल टी ही आता रहेगा प्लांट में फॉर अ लॉट ऑफ जनरेशन। और ये एकदम प्योर टॉल हो गया, इसने स्मॉल टी देखा ही नहीं है कई जनरेशन से। इट इज एब्सोल्यूट प्योर लाइन। सिमिलरली दोनों प्लांट ड्वार्फ ले लो, स्मॉल टी। इन्होंने कैपिटल टी देखा ही नहीं है, यहाँ से स्मॉल टी आया, यहाँ से स्मॉल टी आया, बच्चा स्मॉल टी। इसका फिर स्मॉल टी के साथ आपने ब्रीड करा दिया, फिर आपका स्मॉल टी, फिर स्मॉल टी के साथ करा दिया, बच्चा भी स्मॉल टी, फिर स्मॉल टी के साथ करा दिया, बच्चा भी स्मॉल टी। इसने पिछली कई जनरेशन से कैपिटल टी की शक्ल भी नहीं देखी है, तो मेरे भाई इसमें ड्वार्फनेस एकदम जम गई है। इट इज ऑल्सो प्योर ड्वार्फ, इट इज ऑल्सो प्योर टॉल। इसी प्रकार से मेंडल साहब ने कई प्योर लाइन्स बनाई। ये तो आपका एक कैरेक्टर है। कैरेक्टर कौन सा है, फीचर कौन सा है? प्लांट की हाइट। अब प्लांट की हाइट दो तरीके की हो सकती है, टॉल और ड्वार्फ। तो दोनों की प्योर लाइन बना ली, डोमिनेंट वाले की भी यानी प्योर टॉल की भी, रिसेसिव वाले की भी यानी प्योर ड्वार्फ की भी, दोनों की प्योर लाइन बना के हमने रख ली। तो सिमिलरली मेरे भाई मेंडल साहब ने यहाँ पे 7 कैरेक्टर्स का इस्तेमाल किया। जैसे स्टेम हाइट है तो डोमिनेटिंग हो सकती है आपकी क्या, टॉल, रिसेसिव हो सकती है आपकी ड्वार्फ। फूल का कलर है, डोमिनेंट हो सकता है वायलेट, रिसेसिव हो सकता है आपका व्हाइट। फ्लावर की पोजीशन है एक्सियल यानी एक्सिस पे हो सकता है डोमिनेटिंग, रिसेसिव हो सकता है आपका टर्मिनल। यानी ये वाला अगर आप देखें मेरे भाई, ये वाला अगर आप देखें तो एक्सियल फूल हो सकता है यानी एक्सिस पे, यहाँ एक्सिस पे फूल देखने को मिल सकता है, और टर्मिनल यहाँ देखने को मिल सकता है एकदम टर्मिनस पे। तो इट इज टर्मिनल या एपिकल, एकदम आपका एपेक्स पे देखने को मिल रहा है, टिप पे। एंड दिस इज एक्सियल। तो एक्सियल आपका डोमिनेंट होता है एंड टर्मिनल होता है पॉड की यानी एक्सिस पे फूल देखने को मिल सकता है, और टर्मिनल यहां देखने को मिल सकता है एकदम टर्मिनस पे। तो इट इज अ टर्मिनल या एपिकल एकदम आपका एपेक्स पे देखने को मिल रहा है टिप पे, एंड दिस इज एक्सियल। तो एक्सियल आपका डोमिनेंट होता है एंड टर्मिनल आपका क्या होता है, रिसेसिव होता है। पॉड की यानी फली की अगर आप शेप देखें तो इन्फ्लेटेड, जिसे हम कहते हैं फुल, आपकी पॉड एकदम फली जो है बढ़िया से दिखाई देती है, एंड कॉन्स्ट्रिक्टेड मतलब आपकी पिचकी हुई सी पॉड होती है, इस प्रकार दानों की शेप बनी हुई होती है यहाँ पर। तो ये आपकी क्या हो गई, रिसेसिव हो गई। पॉड का कलर, फली का कलर अगर आप देखें तो ग्रीन है डोमिनेंट और येलो है आपका रिसेसिव। सीड की शेप अगर आप देखें राउंड है, गोल मटोल सीड है आपका डोमिनेंट, और आपका रिंकल है, मुरझाया हुआ सा है रिसेसिव। सीड का कलर अगर आप देखें, ये सबसे इंपॉर्टेंट है, यहाँ येलो होता है डोमिनेंट एंड ग्रीन होता है रिसेसिव। सर येलो सीड डोमिनेंट होता है, हम तो देखते हैं हरी फली में हरे कलर के ही आपके दाने निकलते हैं, यस, जानबूझ के निकलवाए जाते हैं, जानबूझ के ऐसे आपके गैमेट्स तैयार किए जाते हैं, उनको बेसिकली आपका यूज किया जाता है, जिसमें हरी फली से हरा दाना निकले, वो आपका रिसेसिव दाना है। क्यों? क्योंकि अगर मेरे भाई हरी फली से येलो दाना निकल गया तो कई लोगों को जिनको जेनेटिक समझ में नहीं आती, उन्हें लगेगा कि खराब मटर आ गई है, कि हरा पॉड है और पीला दाना है, इसलिए जानबूझ के हरा दाना हम लोग बेसिकली तैयार करवाते हैं, जिससे हरी फली को जब आप खोले तो हरा दाना आपको देखने को मिले, तो आपको लगे मटर ठीक है। तो यहाँ 7 कैरेक्टर्स आपने चुने, और हर कैरेक्टर के दो दो कॉन्ट्रास्टिंग ट्रेट है, जैसे हाइट है आपकी लंबी और छोटी, फूल का कलर है वॉयलेट और व्हाइट, फूल की पोजीशन है एक्सियल टर्मिनल, फली की शेप है इन्फ्लेटेड कंस्ट्रिक्टेड, आपका पॉड का जो कलर है वो है हरा और येलो, जो आपका सीड का शेप है ये राउंड और रिंकल्ड, सीड का कलर है येलो और ग्रीन। तो 7 कैरेक्टर हैं और हर कैरेक्टर के दो दो ट्रेट हैं, यानी 14 ट्रेट हैं। तो मुझे बताइए कितनी प्योर लाइन आपके मेंडल साहब ने बनाई होंगी? गुरुजी 14 प्योर लाइन बनाई होंगी, प्योर टॉल की, प्योर ड्वार्फ की, प्योर वायलेट, प्योर व्हाइट, प्योर एक्सियल, प्योर टर्मिनल, प्योर इन्फ्लेटेड, प्योर कंस्ट्रिक्टेड, प्योर ग्रीन, प्योर येलो, प्योर राउंड, प्योर रिंकल्ड, प्योर येलो, प्योर ग्रीन। टोटल 14 आपकी क्या बनी होंगी? प्योर लाइंस बनी होंगी। तो एक ट्रू ब्रीडिंग वैरायटी वो है जो कि कंटिन्यूअस सेल्फ पॉलिनेशन करती रहती है और एकदम प्योर आपका कोई ट्रेट दिखाती है कई जनरेशन तक। तो 14 ट्रू ब्रीडिंग भी आप लोगों ने तैयार की थी, 14 आपकी प्योर लाइंस बनाई गई थी मेंडल साहब द्वारा, ये हमने देख लिया है। नाउ वी आर अप टू अ वेरी इंपॉर्टेंट टॉपिक, आराम से सुनिएगा। हाइब्रिड फॉर्मेशन की हम बात कर रहे हैं। अगर हम चाहते हैं कि हम हमारे पसंदीदा पॉलन को पसंदीदा फीमेल तक पहुंचाएं, समझ लीजिए ये आपका फीमेल है, फीमेल का स्टिग्मा है, और ये आपका मेल है, इसका पॉलन मैं इस फीमेल पे डालना चाहता हूं। मैं नहीं चाहता इस फीमेल पे कोई और पॉलन आए, मैं चाहता हूं इस फीमेल पे यही स्पेसिफिक पॉलन आए। तो मैं क्या करूंगा, मैं इस फीमेल पार्ट को ढक के रखूंगा जिससे कि कोई और पॉलन ना आ पाए। और ये जो आपका फ्लावर है, ये जो आपका मटर का फ्लावर है, इसके खुद के भी तो आपके पॉलन्स होंगे, इसमें खुद में भी तो मेल पार्ट होगा। जो मटर का फूल है वो तो बाइसेक्सुअल है, तो अगर ये फूल है जिसमें फीमेल पार्ट है, इसमें खुद के भी तो मेल पार्ट होंगे, इन्हें भी मैं काट दूंगा, खुद का पॉलन भी ना आ पाए और किसी और का पॉलन भी ना आ पाए। खुद का पॉलन ना आ पाए, खुद का पॉलन ना आ जाए, इसीलिए मैंने इस मेल पार्ट को ही काट दिया, मेल यानी मस्कुलाइन पार्ट को काट दिया, एंथर को ही रिमूव कर दिया। इसे मैं कहता हूं मास्कुलेशन, डी का मतलब एलिमिनेट कर दिया, मस्कुलाइन पार्ट यानी मेल पार्ट, तो मेल पार्ट मैंने रिमूव कर दिया। करेक्ट है, एकदम करेक्ट है। और मेरे दोस्त यहाँ पे मेल पार्ट मैंने रिमूव कर दिया, तो इसके पॉलन तो इस पे नहीं आ पाएंगे, कोई और अनवांटेड पॉलन भी ना आ पाए, इसीलिए मैंने इस फीमेल को बैग कर दिया है, इसके ऊपर बैग लगा दिया है, थैला लगा दिया है, बैगिंग कर दिया है इसकी। करेक्ट है, एकदम करेक्ट है। अब जब मुझे अपना पसंदीदा पॉलन छिड़कना होगा इस फीमेल पे, मैं बैग को हटाऊंगा, अपना मन पसंदीदा पॉलन डस्ट करूंगा, फिर से बैग को ढक दूंगा, जिससे मेरा पसंदीदा पॉलन ही इस फीमेल के साथ जाके इंटरेक्ट करे, कोई और नहीं। तो मेंडल साहब ने 7 कैरेक्टर्स पे काम किया, 14 प्योर लाइंस यहाँ पे इन्होंने तैयार की, और इस प्रकार से इन्होंने अपने मन पसंदीदा पॉलन को हमेशा अपनी पसंदीदा फीमेल के ऊपर छिड़का, डिजायर्ड पॉलन को डिजायर्ड फीमेल के ऊपर छिड़का, जिससे डिजायर्ड बच्चे बन पाए। यानी समझ लीजिए इन्हें हाइट का इनहेरिटेंस देखना है, तो ये चाहते हैं कि एक पेरेंट जो है फीमेल वाला, एक कैपिटल टी और आपका दूसरा जो है स्मॉल टी तो स्मॉल टी का इन्होंने पॉलन ले लिया और कैपिटल टी की फीमेल ले ली, इसको डस्ट करा दिया फीमेल पे। यानी अपने पसंद के कॉम्बिनेशन ये बना सकते हैं फॉर द हाइब्रिडाइजेशन पर्पस। तो इमास्कुलेशन और बैगिंग टेक्निक का ये इस्तेमाल करते हैं। इमास्कुलेशन यानी एंथर का रिमूवल कर दिया और कोई और पॉलन आकर के ना बैठ जाए फीमेल के ऊपर, इसीलिए बैगिंग भी कर दी। ये करना बहुत जरूरी है जिससे आप मन पसंदीदा हाइब्रिड तैयार कर पाए। करेक्ट। अब मेरे भाई यहां पर देखिए थोड़ी सी जरूरी बात है, हिज एक्सपेरिमेंट्स हैज लार्ज सैंपलिंग साइज। क्योंकि मटर का लाइफ स्पैन काफी कम होता था तो बहुत ज्यादा डेटा आपका तैयार किया जा सकता था बहुत कम टाइम में, तो लार्ज सैंपलिंग साइज हजारों सीड यहां पर बन जाते थे। तो मेंडल साहब के डेटा की क्रेडिबिलिटी बहुत ज्यादा थी। जितना बड़ा डेटा होता है एरर के चांसेस उतने ही कम हो जाते हैं। यस, इन्होंने एक बार में एक ही कैरेक्टर को समझा, इसके बारे में हम बात करेंगे मोनो हाइब्रिड क्रॉस में। इन्होंने मैथ का और स्टैटिस्टिकल डेटा का इस्तेमाल किया फॉर द वेरी फर्स्ट टाइम इन बायोलॉजी। और मेरे भाई ये जो आपके अलग अलग कैरेक्टर्स थे ना, आपके प्लांट की हाइट, पॉड का कलर, पॉड की शेप, ये अलग अलग क्रोमोसोम्स पर पाए जा रहे थे। तो यहाँ पर आपको एक बात देखने को मिलेगी आगे चल के इसी चैप्टर में जब मैं आपको पढ़ाऊंगा लिंकेज के बारे में। तो लिंकेज से भी आपके ये जो मेंडल साहब के एक्सपेरिमेंट थे बहुत ज्यादा इफेक्ट नहीं हुए, अदरवाइज मेंडल साहब का डेटा कभी भी सही नहीं आ पाता, बैंड बच जाती। तो लकी भी थे मेंडल साहब बहुत। यस, तो ये जो आपके अलग अलग कैरेक्टर्स थे ना, इनके जो जीन्स हैं ये डिफरेंट क्रोमोसोम्स पे पाए जा रहे थे, दूर दूर पाए जा रहे थे, तो कोई दिक्कत नहीं आई इनके एक्सपेरिमेंट्स में। ये आगे लिंकेज से थोड़ा सा जोड़ करके मैं आपको बताऊंगा। तो यहाँ पर इन्होंने कई जनरेशन तक अपने एक्सपेरिमेंट को किया बढ़िया तरीके से और खूब सारा डेटा तैयार किया। कैसे इन्होंने अपने एक्सपेरिमेंट्स किए? नाउ इट इज टाइम टू गो प्रैक्टिकली इन द टॉपिक। आराम से समझिए। सबसे पहले इन्होंने किया मोनो हाइब्रिड क्रॉस। नाम है मोनो हाइब्रिड क्रॉस, नाम में घुस जाओ। मोनो का मतलब एक, हाइब्रिड क्रॉस ऐसा क्रॉस आप तैयार कर रहे हो, ऐसा बेसिकली आप कॉम्बिनेशन तैयार कर रहे हो जहां एक कैरेक्टर के इनहेरिटेंस के बारे में आप बात कर रहे हैं। एक कैरेक्टर के इनहेरिटेंस के बारे में आप बात कर रहे हैं, ज्यादा नहीं। यानी इन्होंने अगर एक मेल मटर लिया, एक फीमेल मटर लिया, तो उनमें सारे के सारे कैरेक्टर्स और सारे के सारे ट्रेट सेम हैं, जिससे उन पे ध्यान जाए ही ना। समझ लीजिए मेरे भाई, यहां पर मैंने एक मेल मटर लिया, तो मेल मटर में आपका जो फूल का कलर है ये प्योर वॉयलेट रखा, फीमेल में भी प्योर वॉयलेट, तो सब पे है ही कैपिटल वी कैपिटल वी कैपिटल वी कैपिटल वी, स्मॉल वी बनने का बच्चे में चांस है ही नहीं, पक्का कैपिटल वी ही बनेगा, बच्चे में भी वॉयलेट फूल ही बनेगा। फ्लावर की पोजीशन रखी एक्सियल मेल में और फीमेल में, प्योर एक्सियल, कैपिटल ए मेल में, कैपिटल ए फीमेल में, छोटा ए आने का चांस है ही नहीं, किसी पेरेंट पे छोटा ए है ही नहीं, बच्चे में भी कैपिटल ए यानी एक्सियल फूल बनेगा। पॉड की शेप इन्फ्लेटेड रखी आपकी, प्योर इन्फ्लेटेड मेल और फीमेल में, कैपिटल आई कैपिटल आई कैपिटल आई कैपिटल आई, बच्चों में भी कैपिटल आई ही जाएंगे, प्योर इन्फ्लेटेड ही बनेगा। पॉड का कलर कैपिटल जी कैपिटल जी कैपिटल जी कैपिटल जी ही रखा, बच्चा कैपिटल जी ही बनेगा, प्योर ग्रीन ही बनेगा। सीड का शेप आपका कैपिटल आर ही रखा, बच्चा भी प्योर राउंड ही बनेगा। सीड का कलर कैपिटल वाई ही रखा, बच्चा कैपिटल वाई ही बनेगा, येलो सीड ही बनेगा। डिफरेंस क्या किया? यहां सिर्फ एक कैरेक्टर में डिफरेंस किया मैंने, बाकी सारे सेम रख दिए। एक कैरेक्टर में मैंने डिफरेंस किया, दैट इज इन द स्टेम हाइट। एक पेरेंट में ले लिया प्योर टॉल यानी कैपिटल टी, एक में ले लिया प्योर ड्वार्फ यानी स्मॉल टी। यानी बाकी जो बच्चों के कैरेक्टर्स होंगे भाई, प्योर वॉयलेट ही फूल बनेगा, एक्सेल ही फूल बनेगा, इन्फ्लेटेड ही पॉड बनेगा, ग्रीन ही पॉड बनेगा, राउंड ही सीड बनेगा, येलो ही सीड बनेगा, बाकी सारी चीजें एकदम सेम बनेंगी। फर्क सिर्फ यहां पर आएगा, एक पेरेंट प्योर टॉल लिया, एक पेरेंट प्योर डॉर्फ लिया। बच्चों में हमें बस ये देखना है कितने बच्चे टॉल बने कितने डॉर्फ बने, हमारा पूरा ध्यान सिर्फ एक कैरेक्टर पे जा रहा है, दैट इज एट हाइट। इसे हम कहते हैं मोनो हाइब्रिड क्रॉस। एक ही चीज पे हमारा ध्यान केंद्रित है कि हाइट कैसी होगी बच्चों की, कितने टॉल होंगे कितने डॉर्फ होंगे, इसको हमने मोनो हाइब्रिड क्रॉस कह दिया। यस, तो इनहेरिटेंस आप यहाँ पे देख रहे हैं सिर्फ और सिर्फ एक कैरेक्टर। यस, तो मेंडल साहब ने 2 पी प्लांट लिए जिनमें सारे के सारे ट्रेट्स एकदम सेम है, बच्चों में सारी चीजें सेम जाएंगी एक्सेप्ट वन कैरेक्टर, सिर्फ हाइट का डिफरेंस कर दिया। यहां ले लिया मेल, समझ लीजिए प्योर टॉल, फीमेल ले ली प्योर डॉर्फ। तो मेल है प्योर टॉल तो कैपिटल टी है इसमें, यहाँ स्मॉल टी है इसमें। जब मेरे भाई गैमीट बनाने के टाइम पे मियोसिस होगा तो गैमीट यहाँ बन जाएंगे कैपिटल टी स्मॉल टी, यहाँ कैपिटल टी कॉम्बिनेशन करवा लीजिए भैया, यहाँ से कैपिटल टी आया, यहाँ से स्मॉल टी, कैपिटल टी स्मॉल टी, टॉल हो जाएगा हेट्रोजाइगस टॉल। यहाँ से कैपिटल टी, यहाँ से स्मॉल टी, कैपिटल टी स्मॉल टी, हेट्रोजाइगस टॉल। यहाँ से कैपिटल टी, यहाँ से स्मॉल टी, कैपिटल टी स्मॉल टी, हेट्रोजाइगस टॉल। यहाँ से कैपिटल टी, यहाँ से स्मॉल टी, कैपिटल टी स्मॉल टी, हेट्रोजाइगस टॉल। यानी फर्स्ट जनरेशन में, F1 जनरेशन में, जिसे फिलियल 1 जनरेशन कहा जाता है, इसमें सारे बच्चे एक जैसे बने, एक ही पेरेंट पे गए। ये भी टॉल था पेरेंट, सारे बच्चे भी टॉल बने। प्योर टॉल नहीं बने, लेकिन दिखने में तो एक ही पेरेंट जैसे हैं, सारे टॉल हैं। तो इन F1 सारे बच्चे आपके एक ही पेरेंट जैसे बने, टॉल बने, कोई भी आपका ड्वार्फ नहीं था, यानी कोई ब्लेंडिंग नहीं हुई। बीच का बच्चा नहीं है कोई कि कैपिटल टी स्मॉल टी है तो हाइट मीडियम हो गई। ये जो कैपिटल टी है ये डोमिनेंस की तरफ ले जाता है, यही डोमिनेट करता है स्मॉल टी पे। स्मॉल टी को एक्सप्रेस नहीं करने देगा, खुद एक्सप्रेस करेगा, तो बच्चा कैसा हो गया, टॉल हो गया। अब मैं ये जो प्लांट आया है इसकी सेल्फिंग करा देता हूं, यानी इसी का पॉलन लिया, इसी का फीमेल गैमेट लिया, कैपिटल टी स्मॉल टी का, कैपिटल टी स्मॉल टी से ही मैं क्रॉस करा देता हूं, इसे सेल्फिंग कहते हैं। मैं इसकी सेल्फ पॉलिनेशन अगर करा देता हूं तो सेल्फिंग में क्या हुआ, ये है कैपिटल टी स्मॉल टी, इसका कैपिटल टी स्मॉल टी से ही मैंने क्रॉस करा दिया। तो यहां गैमेट बनेंगे कैपिटल टी और स्मॉल टी, कैपिटल टी और स्मॉल टी। तो कैपिटल टी स्मॉल टी, कैपिटल टी स्मॉल टी, इनको हम एक बॉक्स के किनारों पे रख देते हैं। कैपिटल टी स्मॉल टी इधर एक पेरेंट के जो गैमेट है, और कैपिटल टी स्मॉल टी इधर दूसरे पेरेंट के जो गैमेट है। एक डब्बा सा बन जाता है, इस डब्बे को हम कहते हैं पुनेट स्क्वायर। एक ब्रिटिश जेनेटिसिस्ट थे, एक अंग्रेज जेनेटिसिस्ट थे, जिनका नाम था मिस्टर रेजिनाल्ड सी पुनेट। इन पुनेट साहब के नाम पे ये स्क्वायर हमने तैयार किया। इन्होंने कहा था कैलकुलेशन इजी हो जाएगी अगर आप दोनों एक्सिस पे गैमेट रख देते हो। जैसे कैपिटल टी जब इस कैपिटल टी से टकराएगा बच्चा बनेगा कैपिटल टी कैपिटल टी, ये कैपिटल टी जब इस स्मॉल टी से टकराएगा बच्चा बनेगा कैपिटल टी स्मॉल टी, ये कैपिटल टी जब इस स्मॉल टी से टकराएगा बच्चा बनेगा कैपिटल टी स्मॉल टी, और ये स्मॉल टी जब इस स्मॉल टी से टकराएगा बच्चा बनेगा स्मॉल टी स्मॉल टी। तो आसानी से रिजल्ट यहां पर आ जाता है, आसानी से आपको रिजल्ट देखने को मिलता है। करेक्ट। तो मेरे भाई ये जो F2 जनरेशन आई है, सेकंड जनरेशन आई है, फिलियल 2 जनरेशन आई है, इसमें अगर आप रिजल्ट देखो तो फिनोटाइप कितने टाइप के आ रहे हैं। फिनोटाइप मतलब कितने अलग अलग टाइप की अपीयरेंसेस आ रही हैं, जो आप देख के बता दोगे भैया कैपिटल टी भी टॉल होता है, कैपिटल टी स्मॉल टी भी टॉल, कैपिटल टी स्मॉल टी भी टॉल, स्मॉल टी ड्वार्फ। 3 आपके टॉल है, एक आपका ड्वार्फ है, तो आंसर आ गया 3:1, 3:1। 3 टॉल और 1 ड्वार्फ, 3:1 आपका फिनोटिपिक रेशियो आ गया। जीनोटिपिक रेशियो क्या आ गया मेरे भाई मेरे बंधु, जीनोटिपिक रेशियो क्या है, अलग अलग टाइप के जीनोटाइप कौन से हैं, कैपिटल टी सिर्फ एक है, कैपिटल टी स्मॉल टी ये दोनों है, और स्मॉल टी ये एक है। यानी एक प्योर टॉल, एक प्योर ड्वार्फ, और 2 आपके हो गए हेट्रोजाइगस टॉल। तो 3 प्रकार की कॉम्बिनेशंस है, कैपिटल टी 1, कैपिटल टी स्मॉल टी 2, और स्मॉल टी आपका 1। तो 1:2:1 आपका जीनोटिपिक रेशियो है, 3:1 आपका फिनोटिपिक रेशियो है, जो आपको देखने को मिला। राइट। यानी सबसे पहले मेंडल साहब ने एक टॉल, प्योर टॉल मटर लिया, प्योर टॉल मटर लिया। प्योर टॉल मटर मतलब इसमें समझ लीजिए ये जो क्रोमोसोम है इस पे भी कैपिटल टी है, ये जो क्रोमोसोम है इस पे भी कैपिटल टी है, ये प्योर टॉल है। तो इसके पेरेंट्स से इसके पास कैपिटल टी आया, तो इसमें भी कैपिटल टी जब ये गैमीट बनाएगा तो इनमें भी कैपिटल टी चला जाएगा, चला गया। यहां पर ये जो फीमेल ली इसमें स्मॉल टी आया इसके पेरेंट्स से, तो जब ये गैमीट बनाएगी इसमें भी स्मॉल टी होगा। ये कैपिटल टी, ये स्मॉल टी, आपका नया बच्चा तैयार कर बैठे जिसमें कैपिटल टी स्मॉल टी देखने को मिलेगा। सब करेक्ट है गुरु, ये हमें देखने को मिला। अब मैं इसकी अगर सेल्फिंग करा दूं, ये है समझ लो कैपिटल टी स्मॉल टी, और ये भी है कैपिटल टी स्मॉल टी, कैपिटल टी स्मॉल टी, कैपिटल टी स्मॉल टी। अब इनके जो गैमीट बनेंगे कैसे बन जाएंगे, एक में कैपिटल टी जाएगा, एक में स्मॉल टी जाएगा, और यहां भी एक में कैपिटल टी जाएगा, एक में स्मॉल टी जाएगा। एक पुनेट स्क्वायर में इन सारी की सारी कॉम्बिनेशंस को बना करके जब आप सॉल्व करेंगे, फिनोटिपिक रेशियो मिलेगा कि भैया 3 जो बच्चे हैं वो टॉल हैं दिखने में, चाहे प्योर टॉल हो चाहे हेट्रोजाइगस टॉल हो, 3 बच्चे टॉल दिख रहे हैं, एक बच्चा ड्वार्फ दिख रहा है। और जब जीनोटिपिक रेशियो की बात होगी, एक प्योर टॉल है कैपिटल टी, 2 है आपके कैपिटल टी स्मॉल टी, और 1 है स्मॉल टी, तो आपका ड्वार्फ बच्चा भी देखने को मिलेगा। 1:2:1 इज द जीनोटिपिक रेशियो, 3:1 इज द फिनोटिपिक रेशियो, ये आपको देखने को मिलेगा। देखिए बहुत गौर से। मेंडल साहब ने क्या कहा, मेंडल साहब ने मोनोहाइब्रिड क्रॉस होने के बाद कहा, मेंडल स्टेटेड कि कुछ तो ऐसा है, समथिंग इज बीन स्टेबली पास्ड डाउन। मेंडल साहब ने कहा कुछ तो ऐसा है जो पेरेंट्स से बच्चों में जा रहा है, स्टेबली जा रहा है, बिना चेंज हुए अनचेंज्ड जा रहा है, फ्रॉम पेरेंट्स टू ऑफस्प्रिंग, जिसे मेंडल साहब ने फैक्टर कहा, जिसे आज के दिन में हम जीन कहते हैं। यानी मेंडल साहब ने कहा कि पेरेंट्स से बच्चों में कोई तो ऐसी चीज है जो इंफॉर्मेशन के फॉर्मेट में जा रही है। मेंडल साहब ने कहा कि कोई तो फैक्टर है जो आपका पेरेंट्स से बच्चों में जा रहा है, जो उनको टॉल या ड्वार्फ बनाता है। आज के दिन में हम इस चीज को जीन कहते हैं, विच इज कॉल्ड एज द यूनिट ऑफ इनहेरिटेंस, लेकिन मेंडल साहब ने फैक्टर शब्द का इस्तेमाल किया था और कहा था ये स्टेबल है। स्टेबल किस लिए कहा था? मेंडल साहब ने स्टेबल इसलिए कहा था कि बच्चे या तो टॉल ही बन रहे हैं, ड्वार्फ ही बन रहे हैं, बीच के नहीं है, कोई ब्लेंडिंग नहीं हो रही, देयर इज नो ब्लेंडिंग। बीच का बच्चा नहीं बन रहा है कि मेरे भाई अगर कैपिटल टी और स्मॉल टी साथ साथ आ रहे तो बच्चे का साइज भी इंटरमीडिएट हो गया। बच्चा या तो टॉल है या ड्वार्फ है, कोई ब्लेंडिंग नहीं है, तो स्टेबली ये आपके पास होते हैं फ्रॉम वन जनरेशन टू द नेक्स्ट जनरेशन। तो मेंडल साहब ने मोनोहाइब्रिड क्रॉस के आधार पे दो रूल दिए, दैट इज फर्स्ट रूल और सेकंड रूल, या फर्स्ट लॉ और सेकंड लॉ। फर्स्ट लॉ को बोलते हैं हम लॉ ऑफ डोमिनेंस भी, एंड सेकंड लॉ को बोलते हैं लॉ ऑफ सेग्रीगेशन। ये लॉ मेंडल साहब ने दिए ऑन द बेसिस ऑफ मोनोहाइब्रिड क्रॉस। एक और लॉ दिया था जिसे हम कहते हैं लॉ ऑफ इंडिपेंडेंट असॉर्टमेंट, वो इन्होंने डाइहाइब्रिड क्रॉस के बेसिस पे दिया था। अगला एक्सपेरिमेंट जो हम करेंगे, मोनोहाइब्रिड क्रॉस के बेसिस पे इन्होंने सिर्फ दो लॉ दिए, फर्स्ट लॉ एंड सेकंड लॉ, यानी लॉ ऑफ डोमिनेंस एंड लॉ ऑफ सेग्रीगेशन, ये इन्होंने दिए। अब ये लॉ ऑफ डोमिनेंस, लॉ ऑफ सेग्रीगेशन क्या है, ये भी हम धीरे धीरे पढ़ेंगे, आराम आराम से पढ़ेंगे, ठीक है। इतनी बातें हम लोग कर चुके हैं एनसीईआरटी में, इनके बारे में हम जान लेते हैं। यस, यहाँ पर अगर आप एक ही कैरेक्टर के इनहेरिटेंस के बारे में पढ़ रहे हैं कि एक कैरेक्टर आपके पेरेंट्स से आपके अंदर कैसे आया, तो इसे मोनोहाइब्रिड क्रॉस कहते हैं, जिसका फिनोटिपिक रेशियो 3:1 आया, जीनोटिपिक रेशियो 1:2:1 आया। ये हम अच्छे तरीके से जानते हैं, बढ़िया तरीके से जानते हैं। नाउ इट इज वेरी इंपॉर्टेंट टू अंडरस्टैंड कि दोनों के दोनों रूल्स क्या हैं। दोनों के दोनों रूल्स को समझ लेते हैं बढ़िया तरीके से, आराम से देखिए। सबसे पहला जो रूल है यहाँ पर, सबसे पहला जो लॉ है, इसे हम कहते हैं लॉ ऑफ डोमिनेंस। लॉ ऑफ डोमिनेंस में हम लोग क्या कहते हैं, लॉ ऑफ डोमिनेंस में एक एक चीज को समझने की कोशिश करेगा अकॉर्डिंग टू द स्टेटमेंट। सबसे पहले मेंडल साहब कहते हैं कैरेक्टर्स आर कंट्रोल्ड बाय डिस्क्रीट यूनिट्स कॉल्ड फैक्टर्स। मेंडल साहब ने कहा कि कोई भी कैरेक्टर अगर आपकी बॉडी शो कर रही है, अगर समझ लीजिए मटर का प्लांट लंबा हो जाता है, इसका मतलब मटर के प्लांट को लंबा बनाने वाला फैक्टर है, उसके अंदर कैपिटल टी है। चाहे दोनों ही कैपिटल टी हो, भाई यहाँ पर दो सेट ऑफ क्रोमोसोम है, कैपिटल टी है तो भी मटर लंबा, कैपिटल टी स्मॉल टी है तो भी मटर लंबा। लेकिन हम कह तो रहे हैं कि मटर के प्लांट को टॉल बनाने वाला फैक्टर है, कैपिटल टी होना तो चाहिए। और मटर के प्लांट को छोटा बनाने वाला, ड्वार्फ बनाने वाला फैक्टर भी होना चाहिए, स्मॉल टी, तभी वो ड्वार्फ बन पाएगा। यानी ये जो आपके कैरेक्टर्स हैं, ये कौन कंट्रोल करते हैं? डिफरेंट फैक्टर्स कंट्रोल करते हैं। डिस्क्रीट फैक्टर्स यानी डिफरेंट फैक्टर्स। हर कैरेक्टर का डिफरेंट फैक्टर होता है, हर कैरेक्टर का डिफरेंट फैक्टर होता है। कोई हाइट कंट्रोल करता है, कोई पॉड का कलर कंट्रोल करता है, कोई पॉड की शेप कंट्रोल करता है, कोई सीड का कलर कंट्रोल करता है, कोई सीड की शेप कंट्रोल करता है। हर डिफरेंट कैरेक्टर के लिए डिफरेंट आपके पास जीन्स या फैक्टर्स होते हैं। ये फैक्टर पेयर में पाए जाते हैं गुरुजी, ये भी हमें पता है। जैसे समझ लीजिए यहाँ पर ये आपका टॉल प्लांट है, तो कैपिटल टी का पेयर बना, या कैपिटल टी स्मॉल टी का पेयर बना। अगर ये ड्वार्फ प्लांट है तो स्मॉल टी का पेयर बना। दो सेट ऑफ क्रोमोसोम है, यहाँ भी कोई अलील होगा, यहाँ भी कोई अलील होगा, तो ये पेयर में पाए जाएंगे, सीधी सी बात है, तो ये पेयर में पाए जाएंगे। अगर आपका पेयर सिमिलर है कैपिटल टी तो प्लांट के पास चुनने का ऑप्शन ही नहीं है, सीधा लंबू हो जाएगा प्लांट। अगर आपका पेयर है स्मॉल टी तो भी चुनने का ऑप्शन नहीं है, कोई कैपिटल टी है ही नहीं, तो प्लांट आपका ड्वार्फ हो जाएगा। लेकिन जब ये आपके फैक्टर्स डिसिमिलर होते हैं कैपिटल टी और स्मॉल टी, तो अब प्लांट के पास चुनने का मौका है इन डिसिमिलर पेयर, जब आपका डिसिमिलर पेयर होता है फैक्टर्स का, तो वन मेंबर जो है ऑफ द पेयर इट डोमिनेट्स एंड अदर डू नॉट डोमिनेट। तो ये क्या हो गया, ये जो कैपिटल टी है ये डोमिनेटिंग अलील होता है, और जो ये आपका स्मॉल टी है ये आपका रिसेसिव अलील हो जाता है। डोमिनेटिंग और रिसेसिव यहाँ पर आपको कंडीशन देखने को मिल जाती है, इसीलिए आप क्या कहते हो, यहाँ पे कैपिटल टी जो है ये डोमिनेट कर जाता है तो प्लांट आपका टॉल हो जाएगा, और ये जो स्मॉल टी है ये कुछ नहीं कर पाया तो प्लांट जो है आपका टॉल ही रहा, डॉर्फनेस का उस पर कोई फर्क नहीं पड़ा। अब मेरे भाई ऐसा होता क्यों है, ऐसा हुआ क्यों कि कैपिटल टी जो है ये स्मॉल टी पे भारी पड़ गया। ये जो कैपिटल टी है डोमिनेंट अलील जो है ये आपका वाइल्ड टाइप का होता है, यानी अनमोडिफाइड होता है, यानी इसमें कोई मॉडिफिकेशन या चेंजेस नहीं हुई, तो ये नॉर्मल है। ये क्या हुआ, ये आपका वाइल्ड है जो शुरू से पाया जा रहा था, या नॉर्मल है। तो ये क्या करेगा, नॉर्मल है तो ये क्या करेगा, नॉर्मल एंजाइम बनाएगा जो कि प्लांट को टॉल कर देगा। ये नॉर्मल एंजाइम बनाएगा, नॉर्मल फंक्शन करेगा, नॉर्मल काम करेगा। जबकि ये जो रिसेसिव है ये आपका मॉडिफाई हो जाता है, चेंज हो जाता है, यानी इसमें म्यूटेशन आ जाती है, म्यूटेंट हो जाता है। तो मेरे भाई या तो ये नॉर्मल एंजाइम बना लेगा, ये भी केस है ना, लेस एफिशिएंट एंजाइम बना लेगा, थोड़ा बहुत कम एफिशिएंट होगा पर काम कर ले जाएगा, या ये नॉन फंक्शनल एंजाइम बनाएगा, एकदम कबाड़ा हो गया एंजाइम का, कोई काम नहीं कर रहा है, या हो सकता है कोई एंजाइम बना भी ना पाए। यानी इसमें क्या क्या केस हो सकते हैं, पहला केस लेस एफिशिएंट एंजाइम जो कि भाई काम कर लेगा, थोड़ा सा स्लोली काम करेगा लेकिन कर लेगा, तो ये नॉर्मल कंडीशन ही मान लो आप। या हो सकता है मेरे भाई आपका लेस एफिशिएंट एंजाइम के बाद नॉन फंक्शनल एंजाइम, ये आपका काम ही ना कर सके, ये भी बन सकता है। एंड मेरे भाई तीसरा यहां पर हो गया है नो एंजाइम। अब बताओ क्या चुनोगे, अब चुनने का ऑप्शन है। अगर आपके पास कैपिटल टी केस है तो चुनने का ऑप्शन है नहीं, बच्चा टॉल ही होगा। स्मॉल टी है तो चुनने का ऑप्शन है ही नहीं, बच्चा पक्का डॉर्फ होगा। लेकिन अगर कैपिटल टी स्मॉल टी है आपके पास तो चुनने का ऑप्शन है, या तो चुन लो नॉर्मल एंजाइम, गारंटीड है कि नॉर्मल एंजाइम बने, या तो इसको चुन लो कैपिटल टी को, या तुक्का खेल जाओ, दाव खेल जाओ कि नॉर्मल एंजाइम भी बन सकता है जो कि थोड़ा स्लो काम करेगा, या हो सकता है कोई ठीक से काम करने वाला एंजाइम बने ही ना, कोई काम ही ना हो पाए बॉडी में, या कोई एंजाइम ही ना बने। इन दोनों केसेस में आप बीमार पड़ जाओगे। आपकी बॉडी में हर एंजाइम की वैल्यू है, हर एंजाइम कोई ना कोई इंपॉर्टेंट काम करा रहा होता है। अब यहाँ अगर एंजाइम नहीं बना या बन भी रहा है और काम नहीं कर रहा तो आपकी बॉडी में मेटाबॉलिक एरर्स आ जाएंगे ना, तो ये दोनों केसेस तो आपकी जान भी ले सकते हैं। तो हम क्या करेंगे भैया, हम अब देखो भाई कोई बड़ी समस्या को मुंह नहीं लगाना चाह रहे, इसलिए हम नॉर्मल वाले पे जाएंगे। इसीलिए एक अलील जो है ये डोमिनेटिंग होता है, इसी को चुना जाता है क्योंकि देयर आर वेरी हाई चांसेस कि सही निकलेगा। यहाँ सही भी निकल सकता है और गलत भी निकल सकता है, बहुत रेयर केस है, यहाँ सही भी निकल सकता है। तो अगर ये स्मॉल टी है तो मेरे भाई ठीक है, उस केस में तो चॉइस है नहीं, जहां चॉइस है वहां तो अच्छा चुनो, इससे तो बेहतर है ये वाला, इसीलिए इसको चुनते हैं। हमारी बॉडी इस प्रकार से तैयार की गई है कि हमारे लिए अच्छा चुनती है, इसीलिए लॉ ऑफ डोमिनेंस काम कर रहा होता है। दो में से हम बेहतर को चुनते हैं जो नॉर्मल एंजाइम बनाता है। ये केस तो आपका नॉर्मल है लेकिन ये दोनों नॉर्मल नहीं है, इसीलिए हम इससे डरते हैं, इसीलिए हमने डोमिनेट वाले को ही चुना। दूसरा जो रूल है ये है आपका रूल ऑफ सेग्रीगेशन, या इसे लॉ ऑफ प्योरिटी ऑफ गैमेट्स भी कहते हैं। ये आपका यूनिवर्सल रूल भी कहलाता है, जब भी गैमेट बनेंगे ये रूल फॉलो होगा ही होगा। यस, दिस लॉ इज बेस्ड ऑन द फैक्ट दैट alleles डू नॉट शो एनी ब्लेंडिंग। अलील्स जो है साथ में ब्लेंड नहीं होते, यानी अगर आपका कैपिटल टी और स्मॉल टी साथ पाया जा रहा है तो इंटरमीडिएट हाइट नहीं होगी, आपका लॉ ऑफ डोमिनेंस की वजह से टॉल हाइट हो जाएगी। जो अलील्स है ये ब्लेंडिंग शो नहीं करते, इसीलिए F2 जनरेशन में दोबारा आपके ड्वार्फ बच्चे आ गए थे, 4 में से एक बच्चा ड्वार्फ था, वापस लौट आई थी ड्वार्फनेस। यस, पेरेंट जो है इनमें दो अलील पाए जाएंगे ड्यूरिंग गैमीट फॉर्मेशन। फैक्टर्स जो हैं यानी आपके अलील्स जो है ये सेग्रीगेट हो जाएंगे फ्रॉम वन अनदर, जिससे कि हर गैमीट में सिर्फ एक ही अलील जाए, दो में से आपका एक ही अलील जाए, तो गैमीट्स आर ऑलवेज प्योर। इसलिए गैमीट्स आर ऑलवेज प्योर क्या बोले, बहुत आसानी से समझेंगे। समझ लीजिए यहां पर ये है कैपिटल टी और यहां ये है स्मॉल टी, यहां ये मटर बाबू है, इसमें है कैपिटल कैपिटल टी अलील स्मॉल टी अलील, क्या दोनों एक गैमीट में जाएंगे? नहीं सर, जब गैमीट बनेगा तो इन सेट्स ऑफ क्रोमोसोम्स को हम लोग सेपरेट कर देंगे। एक गैमीट में सिर्फ कैपिटल टी जाएगा, एक में सिर्फ स्मॉल टी जाएगा, यानी दोनों गैमीट प्योर हैं। इसमें कैपिटल टी है स्मॉल टी नहीं, इसमें स्मॉल टी है कैपिटल टी नहीं। जब ये आपके सेट ऑफ क्रोमोसोम सेपरेट होंगे तो इनमें जो अलील पाए जाते हैं ये भी आपके सेपरेट हो जाएंगे, इसलिए इसे कहा जाता है लॉ ऑफ सेपरेशन, लॉ ऑफ सेग्रीगेशन या लॉ ऑफ प्योरिटी ऑफ गैमीट। और जब भी गैमीट बनेगा तो आपके अलील से सेपरेट हो जाएंगे, ये एक यूनिवर्सल बात भी है, तो इसे यूनिवर्सल लॉ भी हम लोग कह सकते हैं। ब्लड जब भी गैमीट बनेंगे ये रूल फॉलो होगा ही होगा। यस, this law is based on the fact that alleles do not show any blending। alleles जो है साथ में ब्लेंड नहीं होते, यानी अगर आपका कैपिटल टी और स्मॉल टी साथ पाया जा रहा है तो इंटरमीडिएट हाइट नहीं होगी, आपका लॉ ऑफ डोमिनेंस की वजह से टॉल हाइट हो जाएगी। जो alleles है ये ब्लेंडिंग शो नहीं करते, इसीलिए F2 जनरेशन में दोबारा आपके ड्वार्फ बच्चे आ गए थे, 4 में से एक बच्चा ड्वार्फ था, वापस लौट आई थी ड्वार्फनेस। यस, पेरेंट जो है इनमें दो अलील पाए जाएंगे। ड्यूरिंग गैमीट फॉर्मेशन फैक्टर्स जो हैं यानी आपके अलील्स जो है ये सेग्रीगेट हो जाएंगे फ्रॉम वन अनदर, जिससे कि हर गैमीट में सिर्फ एक ही अलील जाए, दो में से आपका एक ही अलील जाए, तो गैमीट्स आर ऑलवेज प्योर। इसलिए गैमीट्स आर ऑलवेज प्योर, क्या बोले, बहुत आसानी से समझेंगे। समझ लीजिए यहां पर ये है कैपिटल टी और यहां ये है स्मॉल टी, यहां ये मटर बाबू है, इसमें है कैपिटल टी अलील स्मॉल टी अलील, क्या दोनों एक गैमीट में जाएंगे? नहीं सर, जब गैमीट बनेगा तो इन सेट्स ऑफ क्रोमोसोम्स को हम लोग सेपरेट कर देंगे। एक गैमीट में सिर्फ कैपिटल टी जाएगा, एक में सिर्फ स्मॉल टी जाएगा, यानी दोनों गैमीट प्योर हैं। इसमें कैपिटल टी है स्मॉल टी नहीं, इसमें स्मॉल टी है कैपिटल टी नहीं। जब ये आपके सेट ऑफ क्रोमोसोम सेपरेट होंगे तो इनमें जो अलील पाए जाते हैं ये भी आपके सेपरेट हो जाएंगे, इसीलिए इसे कहा जाता है लॉ ऑफ सेपरेशन, लॉ ऑफ सेग्रीगेशन या लॉ ऑफ प्योरिटी ऑफ गैमीट। और जब भी गैमीट बनेगा तो आपके अलील से सेपरेट हो जाएंगे, ये एक यूनिवर्सल बात भी है, तो इसे यूनिवर्सल लॉ भी हम लोग कह सकते हैं। तो एक कैपिटल टी स्मॉल टी जो है यहाँ ब्लेंडिंग नहीं होती, प्योर टॉल आपको यहाँ पर बच्चा देखने को मिलता है, करेक्ट। अब देखो मेरे भाई, ये तो है लॉ ऑफ डोमिनेंस एंड लॉ ऑफ सेग्रीगेशन जो हमने पढ़ा। अब कई बार क्या होता है, इन लॉज के आपको एक्सेप्शंस भी देखने को मिलते हैं। कई बार ये जो लॉ है अच्छे तरीके से फॉलो नहीं हो पाते तो इनके एक्सेप्शनल केसेस भी आपको देखने को मिलते हैं। ऐसे ही कुछ एक्सेप्शनल केसेस को हम लोग अभी समझने वाले हैं। सबसे पहला जो एक्सेप्शनल केस है इसे हम कहते हैं इनकम्प्लीट डोमिनेंस। नाम के अंदर घुस जाइए मेरे भाई, इनकम्प्लीट डोमिनेंस। जो बच्चा बना वो इनकम्प्लीट डोमिनेंस से बना है, यानी वो दोनों पेरेंट जैसा ही नहीं है, ना वो मदर पेरेंट पे गया ना वो फादर पेरेंट पे गया, दोनों में से कोई भी डोमिनेट नहीं कर पाया, वो अलग ही तीसरा ही आपका कॉम्बिनेशन में बना है। ना वो मदर पेरेंट जैसा है ना वो फादर पेरेंट जैसा है, कोई भी डोमिनेट नहीं कर पाया, अपनी मर्जी नहीं चला पाया, बच्चा अलग ही प्रकार का बना है। इसे हम कहते हैं इनकम्प्लीट डोमिनेंस, जो कार्ल कॉरेंस ने डिस्कवर करी थी। चाहो तो ये बात छोड़ सकते हो, मिराबिलिस जलापा में आपको ये एक्सपेरिमेंट होता हुआ देखने को मिलता है। अलग अलग फ्लावर्स में आप ये एक्सपेरिमेंट कर सकते हो, मिराबिलिस जलापा में भी कर सकते हो। यस, आप स्नैपड्रैगन या डॉग फ्लावर में भी कर सकते हो, है ना। आप 4 o'clock प्लांट में भी कर सकते हो, स्नैपड्रैगन या डॉग फ्लावर में भी कर सकते हो, एंटी रेहिनियम मेजस में भी कर सकते हो। अलग अलग एग्जांपल्स यहाँ पर दिए जाते हैं। पर यहाँ पर क्या हुआ, जो बच्चा है, जो F1 में बच्चा बना, जो पेरेंट्स का बच्चा बना, इट डू नॉट रिजेंबल ईदर ऑफ द टू पेरेंट्स। ये बच्चा दोनों पेरेंट जैसा ही नहीं था, यानी दोनों पेरेंट ही डोमिनेंट नहीं रह पाए, दोनों पेरेंट ही डोमिनेंस शो नहीं कर पाए। इसे इनकम्प्लीट डोमिनेंस कहा जाता है या पार्शियल डोमिनेंस कहा जाता है। इनकम्प्लीट डोमिनेंस, दोनों पेरेंट जैसा ही नहीं निकला बच्चा। क्या हुआ, गौर से सुनिए। यहां पर देखिए, आपका एक जो आपने पेरेंट लिया ये है कैपिटल आर, यानी इसमें रेड फूल है, कैपिटल आर। एक में आपने लिया स्मॉल आर जिसमें व्हाइट फूल है। अब जब इनके गैमीट आप बनाओगे तो कैपिटल आर से आपका कैपिटल आर आ गया गैमीट में, स्मॉल आर से स्मॉल आर आ गया आपका गैमीट में। अब ये कैपिटल आर स्मॉल आर जब आप मिक्स कराओगे तो कैपिटल आर स्मॉल आर जब बना तो इसको टेक्निकली क्या होना चाहिए था सर, कैपिटल आर स्मॉल आर, कैपिटल आर डोमिनेटिंग होना चाहिए था, तो बच्चा रेड फ्लावर का होना चाहिए था। रेड फ्लावर लेकर बैठा होना चाहिए था, यहाँ पिंक फूल बना। यानी ना ये रेड है ना ये व्हाइट है, पिंक बन गया। दोनों की ही मर्जी नहीं चली, दोनों ही डोमिनेंट नहीं रह पाए, इसे इनकम्प्लीट डोमिनेंस हम लोगों ने कह दिया। फिर इस कैपिटल आर स्मॉल आर की जब सेल्फिंग करी तो कैपिटल आर स्मॉल आर यहाँ गैमिट बने, कैपिटल आर स्मॉल आर यहाँ गैमिट बने।
Yo, horse, how are you doing? So sorry that I didn't respond to your messages. Sometimes I'm so locked in that I don't see other people's messages. I'm studying biology genetics. Do you remember monohybrid and dihybrid cross? Do you remember that? How are you doing? I mean, I'm not sure whether you're there. Yo, 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 yeah. So, do you remember? Yeah, what's up? I'm doing fine, bro. What about you? How? What's up? Oh, yeah. White roof, by the way. I'm just joking. I'm doing well. What about you? And do you remember? Can you hear me now? Hello? One minute. Can you hear? Can, can you hear me now? Yes, I guess. So I just wanted to mention that how are you doing? Like, are you doing fine? And yeah, I know it's very weird. I'm studying biology genetics. If you don't know, do you remember monohybrid and dihybrid cross that we did in 10th? We are doing that same thing, but with other extra things like test cross, incomplete dominance, co-dominance. We're doing some extra things. We're learning genetics in detail. Yo, crazy dedication. Thank you very much, bro. I appreciate you, horse. I'm fine. How about you? I'm also doing fine, bro. Glad to have you back, by the way. I'm studying from Vipin, sir. Like, I'm actually watching a lecture of genetics. Um, I'll try completing at least dihybrid cross, and then tomorrow I'll try doing recombination and linking, which is a whole new topic that you have not studied in 10th. So yeah, can you hear me? Yo, can you hear me now? I know it's very low. I'm so sorry. Okay. Well, latency is also really strong. Can you hear me now? I guess so. Yeah, that's really strong. Yeah, okay. And wait, I wanna ask you about IPL. Like, I don't watch IPL. I just wanna say that what's the status of your team? Like Sunrisers Hyderabad. Like, how is it doing? And I was also wondering about other teams like PBKS, RCB, and even Gujarat Titans. I don't watch IPL. That's why. I will soon end it. I'll soon end it. Like, I think I will study for like 17 more minutes, and then I will end the stream. I'll save 17 more minutes. Oh yeah. Okay. I'm so sorry for that too because my mic is very low. I meant in IPL, right? Like, what's the status of your team, Sunrisers Hyderabad SRH? What about other teams like Gujarat Titans or PPKS? I don't know what's the full form of that. Then CSK or any team, like especially yours. I wanted to know that. That's it. Is my mic clear or is it like really lagging? Not lagging. Is it like really too low? Yeah, okay, my bad. So yeah, it's fine. It's fine. Oh, nice, nice. That's a good one actually. I see. and I think it's very late at night, and you may be stressed out. I'm just, like doing biology. Yesterday I was like, today it was a lot of things. I had done a lot of things today. Like after school, I just started studying chemistry, then maths, then gave the test, then studied chemistry again, then physics. Like I was doing some really tough level questions, and then finally biology. I was practicing questions of NEET in biology. Anyways, bro, take care and keep pushing. I gotta go sleep. I have maths test today. Sorry, I got maths test tomorrow. All the best for the maths test. I think you meant today itself because it's 12 o'clock already. So yeah, all the best for applied maths. Which chapter? Is it matrices? I'm so sorry to disturb you again. Is it matrices and determinants? I'm so sorry again. Just in case if you're there, I'm telling, the latency is a bit it's big, so I have no idea whether the person is active or not. That's it. Okay, I think he's not there now. Is he? Can I reverse this? I don't know. Oh, good. Thank you, bro. Good luck to you. Bye. Good night. Yes, it's mattresses. Okay, okay. My bad. Okay. Have a great night. Allah Hafiz. All the best. Um, hope you get good marks. Don't worry. Be chill and give the test. I have to also continue. I have to complete it as soon as possible. The biology work. So Allah Hafiz. Alright, guys, I have finished the lecture. Now I will just write that down the notes. And I feel like I have to end the stream because my uncle just came and told me to, like, go sleep. So I have to do it as fast as possible. And laptop setting takes me so much time. So please wait for a while. And I'm sorry for that. And also I'm really sorry that I've gone for a while, like, for like 40, 50 minutes, almost an hour, by the way, which is actually not good. But I think we have covered up many, many, many things. We have completed physics work, we have completed chemistry work, we have partially completed math work, not full. I want to complete many, many parts of mathematics so that I can master the chapter. So I have to take holidays somewhere around next week or this week could be. Then, uh, yeah, and talking about biology, yes, but again, 11th standard portion is must to be concluded with, so that's one thing I have to actually usually try my best to aim for. And if I get any time, and if there's no schoolwork, then I will aim for 11th standard work. So I'm really, really grateful. I've seen many, many viewers who had engaged with me, like Horace, Regina, he, and then who else? Uh, yeah, DIK also, which is pretty weird. Okay, so sorry, I also have a small amount of cold. I have told that last night, and I'll have to end the stream early, and tomorrow is school too. So it's 12:40, right? I have to wake up at 5:30, so it's pretty late. I gotta go sleep now, and till then, see you. Bye. Allah Hafiz.